All right, welcome everyone. It's always a challenge, obviously, to do the switch over from one stream to the next. It's because of LinkedIn. In order for us to stream to LinkedIn, we have to get it under 4 hours, unfortunately, and we're trying to accommodate to that audience as well. So hopefully all of you will be able to switch over. We have refreshed the website. If you haven't done so, this message is not going to reach you, I guess, but that's all right. You'll be able to watch it on the recording. So let's take a look at what's next on the schedule. I know that we were scheduled to have a break, but we went a little bit over time. Apologies for that. Coming up next, we have a really cool session. This is deploying and testing ephemeral environments. I know that Chris is on stage. I was asking if David is going to be here. He may not be here on time, but that's okay. He's running late. That's fine. We'll the show must go on, as we like to say. So anyways, they're going to do a really cool presentation on basically telling the story around how Atlassian was using Octopus, or is using Octopus Deploy and Testry to deploy to ephemeral environments. And given the fact that ephemeral environments is now a first-class citizen in Octopus, the timing for this is actually quite awesome. So, Chris, I'll invite you to stage. Welcome.
Yeah, thank you for having me. Yeah, hopefully David should be joining us soon. I think he's expecting to.
Okay.
But happy to go ahead and get started and dive straight into this.
All right, no worries. If by any chance he doesn't make it, that's fine. I'm here with you off stage, so we'll just forge ahead as we go. I'll add your slides. The stage is yours.
All right, sounds good. Well, thank you everyone for having us. Today we're going to talk about how we deploy and test ephemeral environments at Atlassian by leveraging both Octopus Deploy and Testry. And it works quite nicely together and solves a problem that, frankly, many of us have had in the industry. And so I'm excited to share what we did to solve this problem, but then also share what some of the options are available to you today if you're trying to solve this problem also. So let's talk about, what is the challenge? And the challenge starts with the fact that teams used to build software like this. So to be fair, I started my career in software development over 20 years ago. And when I first started deploying software, we did what was called cowboy coding and would just copy the source code files out to the production server. And now we had a new version out in production. And one day I learned the hard way that I copied the files down from production to my local machine, wiped out a week or two worth of work, that having a deployment process was a good idea. So a bit of an embarrassing story from my past, but that was how I learned to really appreciate the importance of having a good, clean software development pipeline, complete with source control and tests and all that. So the industry's changed quite a bit over the years. But even quite recently, and you might even be doing this today, teams were building software like this. So it starts out with making your code changes on a particular branch. You probably run unit and integration tests on that branch, and probably run all of your unit and integration tests because they're nice and quick. And then if everything passes or anything you haven't ignored passes, then you merge to a development environment, which might deploy to automatically to a dev environment. And then every other week, you might go ahead and create a release branch And the purpose of creating the release branch was so that you could deploy that to a QA environment. And then once deployed to the QA environment, then you would be able to run your automated tests again, targeting your QA environment. And you might be able to also have people manually test the code in that QA environment. So then you would run your end-to-end test, you would fix bugs, might take a day or two. Then you would run your end-to-end test again, fix more bugs, which might take another day or two. And on a 2-week cycle, at that point, it means it's time to release. You would have a go, no-go meeting. And with the go, no-go meeting, sorry, David's just asking a quick question here, trying to join us. So with the go, no-go meeting, then you might decide, okay, there are too many bugs or there aren't too many bugs. But typically in most organizations I worked for or worked with, you would get into that go, no-go meeting and you would decide to just go ahead and ship it anyway based on whatever bugs were happening to be there. So obviously this isn't ideal for a number of reasons. But the biggest reason that it's not ideal was this challenge that we continued to run into. So how many of you, if I were presenting to a room, I'd ask you to raise your hands. I'm not sure I have a good way to do that with the live stream, but think about raising your hand here. You've encountered this problem. I've made a simple code change and now dozens of unrelated tests are failing. As a developer, there's nothing more frustrating than that. You might even just be fixing a simple text change with the bugs. You want to update the text on the website. It's a production hotfix. And you've got to run tests in order to do that. And you're running the tests. And clearly the failing tests have nothing to do with your code change. And so that's really frustrating. It erodes confidence. And it not only erodes confidence in the tests, but it also erodes confidence in the team that's responsible for that test. And eventually, if enough production issues leak out to the customers, it can erode confidence in the company itself within your customer base. So that's a very significant problem by and of itself. But you also have the challenge that this can lead to wasted developer time. And everyone wants to, they keep saying, do more with less. How can we ship as much as we can possibly ship as fast as we can with the team of experts that we have? And so if you're wasting a lot of developer time, obviously that's a problem. So we don't want developers sitting around or testers reviewing failed tests only to find out that these tests are flaky. And that they're not related to the code changes that we're trying to make. And then you also have the issue that it can mask real bugs. So if you just get used to all of your tests or percentage of your tests failing, then if you get used to that, then what ends up happening is eventually your team will start to ignore failing tests because they think that the failing tests have nothing to do with their code change. They just ignore them. And then they don't realize that it was an actual issue. Or another thing I've seen happen is you have a failing test and you're so used to ignoring that failing test that you don't realize if that test were passing, you would get further in the pipeline and find out that there's a newly introduced bug sitting behind that failure that you already expected. So it's really, really important to get your tests passing as quickly as possible. And so that's where the solution comes in. Hi, David. And the solution is to deploy and test your application before you merge the code. And the reason that that's so important is there's a bit of perception versus reality at play here. So the perception we all often hear is, unit and integration tests are good enough. I've heard that a lot. People like to rely on them. They are quick. They are reliable. But the reality is that end-to-end tests catch issues that unit and integration tests simply can't. Why? Well, the reason is that an end-to-end test is actually testing the full stack or the full pipeline. And so you can run into things like configuration issues, environment issues, integrations with third-party systems that just simply aren't executed by your unit tests. And so if you fail to run those end-to-end tests, you won't catch those issues until much later in the process. You also hear that end-to-end tests are too slow. Well, they are technically slower than unit tests, but one of the reasons that they're slower than unit tests is because they actually are testing more than what the unit tests are. So a unit test will mock some behavior of functionality, and the end-to-end test is actually using that real functionality. So of course it's slower. You know, if you're making real API calls, you have to wait for those API calls to complete. But, and this is incredibly important, end-to-end tests aren't too slow to be valuable. So they are slower than unit tests, but they're not too slow to be valuable to your company. In fact, sometimes they're the most valuable tests that you have. They're the things that test your mission critical functionality that end-to-end flows your users count on. You also hear that end-to-end tests are unreliable. Well, this was definitely true when I started writing tests about 20 years ago, and I was one of the early adopters of Selenium. So if you go back and you look, that's about the time Selenium was first coming out. And you know, I definitely ran into a challenge where, you know, the browser instruction was coming all the way from, I was in a data center in Virginia and using Sauce Labs at the time. They had just come out, and I think their data center was in California. And so here I am sending a message all the way from Virginia to California, which is across the United States, asking if I could click on a button. There was a lot that could go wrong in between. And so, of course, those tests initially were unreliable. But there are much better ways to run tests today. Our platform is one of them. And so end-to-end tests are not unreliable. And we'll have some really good evidence of that when David gets to share what his team has been working on and some of the amazing things that they've done here. And then we've also heard changing the framework will solve your problem. So, you know, at first it was, well, we all need to move to Selenium. And then after we all moved to Selenium, it was, well, maybe we all need to move to Cypress. And now a lot of the people who moved to Cypress are saying, well, maybe I need to move to Playwright. If you implement the same tests in different frameworks, it's an expensive path to disappointment. So it might take you 6 months, a year, 2 years to migrate all of your tests over, but you need to investigate why those tests are flaky to begin with. And that's an entire presentation that I have that's outside of the scope of this. So if you're interested in knowing of the flaky reasons for flaky tests, I've got something like 14 really great root causes. Just reach out to me afterwards, and I'm happy to share those with you. And so it turns out the secret to doing effective trunk-based development is to run end-to-end tests before the merge. And so that means that merging code is, or the reason you need to do that is merging code is usually in most environments a commitment to release the feature. Maybe it's not fully baked, but if I merge it into the release branch or even into the development branch, you're queuing that work up for the next release. And that means I either need to fix what I put in there or I need to pull it out. But as soon as I put that code out there, other people on my team are going to start depending on that to base their code changes off of. And so that means in practice, running tests after the merge means your team is basing your changes off broken code. Since they didn't run the tests, they might not know it's broken code, but they are, right? And my personal take on this is that's not just rude. It also puts your release at risk if the broken code is hard to fix. And any of us who've been in painful go, no-go meetings have seen that. We've seen an overambitious feature hit the QA environment too soon. And everybody says, gosh, this would be so hard to unwind. It made a bunch of database changes. The schema is totally different. We can't easily back this out. We're just going to have to hold off on releasing. And the solution to that, and that's what gets us to this topic that we're discussing today and where Octopus Deploy and Testry work so wonderfully together, is with ephemeral environments. So ephemeral environments are short-lived environments that are dynamically provision so that you can deploy and test features before the merge. And the advantages of doing it this way are twofold, really. This gives you an opportunity for manual review and sign off before committing the functionality to the next release. So a product owner might have asked for X, Y, or Z, and now you've implemented what you think is X, Y, or Z. But with an ephemeral environment, you can say, well, here's where it's deployed. Why don't you go look at this before we commit to putting this in the next release? And you might do that back and forth multiple times throughout the day, get a really good result, and then you've decided to put it into the release. So that's pretty exciting. Your infrastructure can also be more representative of what's going to happen in production and potentially handle more parallel tests. As powerful as developer workstations are, they can't handle 200 or 500 or 1,000 parallel tests, but you can actually deploy to a testing grid and then have an ephemeral environment do that if it's representative of your infrastructure. You're also going to catch more issues that way because you have an environment that's closer to what your production environment looks like. And it reduces the variability, which anyone who's been around the Six Sigma world or any type of process improvements manufacturing knows that variability is the enemy of quality. And your local workstation is a source of variability. You might have a different operating system, different versions of browsers, and then you're challenged to say, well, it works on my machine, but I don't know why it keeps failing in CI/CD. And I'd also like to throw in that it's necessary, absolutely necessary when using AI to help with code, that you're also doing ephemeral environments. And the reason why is because we need to know, did AI actually build what we asked it to? Did AI introduce any new regression errors? Not only is the code clean, but does it functionally do what it's supposed to, look the way it's supposed to, before we go off sharing that code with the rest of the team? And if we don't, those same issues that might have crept in before where a developer changed the schema, now it's hard to back out. Just imagine how much more difficult that is when it's not a developer who changed the schema, but AI who completely wiped out everything, changed all your database tables, renamed everything. So this is a really good safety net to be able to check what AI is doing before you merge. And then this is also really cool, is you can actually take the test results now from Testry and you can feed them back into AI to help inform AI how to fix the tests and how to fix the code in order to make the test better. And the ephemeral environment gives you a really nice playground to do that. So here were some of the considerations that David and his team had to work through. David, do you want to share a bit of what you need to implement ephemeral environments at Atlassian?
Yeah. So, hey, my name is Dave Gimbalo. I'm a senior engineering manager at Atlassian. I've been working with Octopus and Testry for better part of 8 years, maybe 8.5. And so we've used them to deploy and test our environments for that whole time. Our product's called Jira Line, or recently remapping to Strategy Collection. There's my quick plug. So we automatically provision our infrastructure. We use today we're using Terraform. We use the same Terraform scripts to define the SaaS implementation for our production, our test, our staging, our sales environments. The Octopus and Testry are tightly integrated into our CI/CD process. We're constantly improving and maturing that environment, finding more issues, making it more and more realistic. And it gives us the ability to do more complex what-if testing, not just on software, but on environmental type changes. So we can change, you have DNS in here, but I could change the way I've configured my Cloudflare. I can change the way I've configured my load balancer. In our implementation, we're using IIS, which obviously most people using Octopus probably do. So we do the CNAME mapping in Cloudflare to the load balancer directly, and then the IIS picks that up afterwards. And we did a transition to every PR creates a website. Geez, how long ago was that, Chris? Like 3 years ago?
Yeah, I think so.
Yeah, so it's pretty slick. So every PR creates a test environment. So we name the site that PR, so it's very obvious. So everybody knows exactly where to look. We've hooked that up to Sentry, so it finds exceptions. We execute the test code, so we have a multi-tier validation process. So it dumps out the system logs to a private Splunk and all sorts of other stuff. But it's really transformed the amount of parallel throughput our engineering teams can do. And I will say that we do the ephemerals, and then so we have two kind of classes of testing. I mean, two classes of delivery. We have essentially every 4 weeks we do an enterprise class release with the feature updates, but then we do daily releases for bug fixes or changes that don't really impact the user interface. So it allows us, this whole process allows us to run that test validation. And I have all the data, I think, later, but we could run through and release within an hour, even running all of the critical end-to-end tests. It's pretty slick.
Yeah, so I think the key part there is, in implementing the ephemeral environments, there are all these considerations that you have to do and a lot of work. And Octopus Deploy was really helpful, right, David, for being able to take what used to be various scripts that were laying around, deployment scripts that would sometimes fail halfway through the deployment. And then an engineer would have to come in at 3 in the morning and figure out where in this process did it fail, update the scripts, redeploy. And by setting everything up in Octopus Deploy, that deployment process was well defined in various steps that could be run by other members of the team and understood by other members of the team.
Yeah, so we were started at that time, so that other person was me. As a reminder.
Yeah, and then also, now that that's running on ephemeral environments, and since that's the topic here, having the same deployment process for your ephemeral environments means you're not only testing your code and you're not only making sure your tests run properly, you're also testing the steps in Octopus Deploy to make sure they're working correctly before that any changes to the deployment process go live. So it's a really cool opportunity to do that. And so, as Dave mentioned, the implementation is Octopus Deploy for deployments, Testry for testing. And the tenants, initially, the way we set it up, and this wasn't exactly popular, but it was a good way to transition from how deployments were working before to something a little closer to doing ephemeral environments. And that was having fixed branches for each tenant. So if somebody deployed to tenant / they were all superheroes, so tenant / Superman would get deployed to the Superman environment. Tenant / Deadpool would get deployed to the Deadpool environment. And then over time, we created runbooks for provisioning the tenants as well as doing maintenance to them. And then we're able to call the testry step in Octopus Deploy to kick off end-to-end tests targeting the tenant. And then over time, now that script is automatically called, and it happens to be a runbook. And so this is where Octopus Deploy's new feature comes in, which is really nice. We just heard that it's a first-class citizen in the platform. Well, it is. If you go into your project now, you'll see it says ephemeral environments, and you can go in and set this up. And what this gives you the opportunity to do is when you define an ephemeral environment, you can say you want to base it on a parent environment. So that probably going to be your development environment, but it's up to you. And it automatically creates a release channel. In this case, I think the default name is ephemeral environments. And so if you kick off a release to ephemeral environments, it's going to deploy that release to an ephemeral environment. And then you say, well, when Dave and his team got all of this set up, they had to have runbooks created and they were automatically running their runbooks whenever things got deployed. Well, what's nice now is that's built into Octopus Deploy as well. So you have a provisioning runbook, which can set up the environment for the tenant. And then you have a deprovisioning runbook. And another nice piece of the functionality here is you also have the ability to set a default deprovisioning window. So Dave, I don't know if you ever got to the point where there were so many environments we didn't know what to do with, and we were wondering if they're all being used. That may or may not have happened, right? So this is a convenient way of saying, okay, we want to automatically deprovision inactive environments after 1 week if nobody's actually using them. So that's really nice. So step one, you can do that today. The next thing to do is to create a release any way you like. So you can do that through the Octopus portal through the website. They have a very nice API. They have a very nice CLI. So the CLI is how we were able to do a lot of the implementation and for ephemeral environments before it actually existed in Octopus. You know, you could make a CLI call to create a tenant, for example. Probably going to get in trouble here. This is my bad. I put GitHub Actions without putting Bitbucket pipelines, I think because I got this from the Octopus website. But you can also do this through Bitbucket pipelines. Don't tell the folks back at Atlassian, Dave. And then step 3 is you can add test tree to your deployment steps. So we're actually available in the Octopus Deploy library. There's a create test run, which gives you the ability to kick off a test run immediately, or you can just report a deployment. If you report a deployment, then in test tree, you're able to configure automatically kicking off test runs based on what's deployed in your environment. So let's say your tests live in one project, like a web project, but anytime the API is deployed, you want to automatically kick off your web tests. That's an easy way you can do that. Anytime Octopus deploys your API, now all of a sudden test tree is running your web tests to make sure that everything's working from an end-to-end perspective. And so in terms of how it works, now developers push a new feature branch and submit a PR. The ephemeral environment is automatically provisioned in Octopus Deploy. That environment automatically gets registered with test tree. So we have a website. We also have an API and a command line interface. And so you have the ability to say test tree, create environment whenever Octopus Deploy is creating the environment. And so that gives us a way to create the environment. The release is created and then pushed to the ephemeral environment. Test tree automatically runs the tests. And we now also support the ability to run different sets of tests depending on the environment, stage, or even code changes. And those tests don't necessarily have to live in the same repositories. They don't necessarily have to be implemented in the same testing frameworks. So we can do whatever kind of complex testing we need to do whenever we have whatever kind of complex deployments we have going on in Octopus Deploy. So really cool and powerful. And so before we dive in and let Dave share some of the results that his team is able to achieve with Octopus Deploy working with test tree, I just want to ask a quick question here. Do you think it's realistic to expect 100% green test runs in your QA environment? And do you think it's reasonable to expect that with your end-to-end tests as well as tests that are written in Selenium? Well, I want Dave to be able to share the results here. Dave, how many times in the last 30 days did your team get 100% green test runs?
Yeah. that never happens. Yeah. Well, I think the green. So we have, I guess we have a couple of concepts. We have a pull request green build process, which is part of our SOC 2 compliance, which is the minimum validation, and that has to pass, right? So there's a final test pass, but if you look at this context we ran, and this is just our end-to-end test, right? We do other stuff as well, but this is, in the last 30 days for the release of our projects, almost 4 million tests, 95% pass rate, which is in practice is actually pretty darn good for that implementation and complexity of our solution. And effectively ran almost 12,000 hours of automation. However you want to define that as work saving, it's kind of par for the course nowadays, but it's pretty wild. It's provided a lot of security and risk. Like we recently completely decommissioned our release management group, right? So we used to have to do validation. Now we don't even meet. It's just completely automated. So for our zero downtime deployment, it's just an exception-based system. So Octopus and test tree, and hardening that solution has made it a no-op, really. So we're pushing fixes to our customers. Our CSAT's been steadily improving.
Yeah, I think that's so important. I remember just how painful it can be when you have the change management meetings of, are we going to be ready for the release? What are we deploying? And then you have this other meeting that's a go, no go. And, you know, before we started Testery, you know, I was a director at QA for a startup, and every 2 weeks I was the person who was supposed to run the go, no go meeting. And, you know, it was painful. Like, everybody works their butt off for 2 weeks, and some people are putting in incredibly long hours. And then somebody last minute throws in something that's untested, really hard to unwind. And now you're going into a go, no go meeting, and everybody's saying, well, you said we were ready to go for the last 12 days. And now you're telling me there's a blocker. Where'd this blocker come from? And why can't we just fix it today? And then you either decide to ship anyway, or you decide to cancel the release. And, you know, it only takes 2 or 3 of those canceled releases in a row for everybody to just say, I have the wrong team in place. And that's a scary place to be as a release manager. And here Dave is saying, well, now that we're running tests before the merge in ephemeral environments, we don't even have to have that meeting. We only have that meeting if for some reason we don't have the test passing. And here, as you can see, the other thing about this slide that we should point out, this is across all environments. We also pulled the numbers for just the QA environments. So just in that final QA check, out of 356,000 tests that were run in 1 month, 99.6% of them were passing. So less than 0.5% failure rate. That's across 2,150 test runs in the QA environment, 750 hours of testing roughly. And then I love this because, you know, I always thought, you know, I was always on the fence, you know, should we back off on, is 100% green unrealistic? In the QA environment, there were 1,892 test runs performed in the last month that were 100% green, which meant nobody had to review failed tests, right? And that to me is just super cool. And so Octopus Deploy, with working together with Testery, has really helped make that happen. You might be wondering how the FTE equivalent is accounted for. This is just, you know, assuming that somebody works 80% of a 40-hour work week, what would that number of hours of equivalent testing be? And so that would be 6 people doing nothing but clicking on buttons for an entire month to account for the amount of testing that took place here.
So yeah, one simple clarification is this QA regression is the final test pass. The prior one was all those other environments like we were talking about, the temporary ones for the PRs.
Yeah. So even on PR environments, you have an incredibly high pass rate. And I think that's pretty cool. Because in a PR environment, and that was why we showed both, is in a PR environment, you do expect test failures, right? If you're making a code change and you're not running all of your tests locally, which isn't practical to do, when you run all of your tests for a PR, you do want some of the tests to fail, but you want it to only be the tests that are related to your change. And so that's really helping with being able to do that by deploying to environments.
Yeah, and let me just, one other quick addition there. The reason we do, you know, so much of our testing in these environments is it's a complicated SaaS environment, right? So the SaaS solution's got Cloudflare, we've got App Dynamics, Penda, we've got other third-party integrations, our Clickstream, our over monitoring solutions, and you can't test those locally. Like we can't create keys for every developer. That's not practical. Mm-hmm. So, you know, if you have any type of mashup integration, which almost every site does, you know, you have to do this kind of in situ site validation.
Yeah, and I would imagine so many of Octopus Deploy customers are either enterprises themselves or companies like yours where the customers are enterprises themselves. And, you know, in that environment, you know, we've got customers that are running different systems on different versions of things that can't practically be deployed to a local developer workstation. That's kind of what you're getting at there.
Yeah, exactly.
And so in order to support enterprise, you really need to have that capability of complex deployments, which Octopus Deploy solves really well as complex testing, which I think Testery solves really well. And that just gives you the full picture of, is this release ready to ship before other people start depending on my code even, which is, that's ultimately how you get to passing tests. And then just to kind of recap some of the impact this has had, Dave, do you want to share, some of the impact of, well, we kind of touched on already, but.
Yeah, I think, man, there's just so many. This is what we do, right? So the release process of the software and the testing process is the critical last step. We've been doing dev productivity. It's a hot item, for a lot of development companies. They want to keep shrinking the time to test and the quality of the test. That's a hot, as an engineering manager, I have roughly 30 people. I got to keep them all happy and wanting to work. And the tools that they use are critical, right? So it's not just the time you save, it's you want to have the best people, because the dev teams go out and chat with each other about whose environment's the best to work on, and this is such a critical element of it. And then I think I touched on it before about our quality and our ability to fix bugs, because bugs happen, right? I mean, there's always a bug. It used to take us, as we've matured, we've been constantly watching it, but in the last since March, it's January, I think we got the zero downtime releases. And that was mostly a function of our Windows implementation, not the tools. But we're turning around bugs same day or just in a few hours. So a customer submits it to our public website, jira.atlassian.com. And, it gets immediately routed to the teams, and the teams know how to fix it. And then we trust the ZDD process and release process. And so we're only involved in exceptions to the process at this point. So we're releasing every day. We don't even have the go no-go meeting. I set them all up, and then we eliminate them just a couple weeks ago. We completely eliminated the release management engineering process. And then now we're able to release around the clock around the world, right? We have data centers in APAC region, EMEA, UK, Ohio, all over the world. And we're able to release the riskier stuff at certain times, and then intentionally release the ZDD stuff in the middle of the day, so we get the most impact. And we do the blue-green deployments and stuff with Octopus as well, which is very, very cool. The list is too long, so maybe I'll just stop there.
Yeah, so I think that gives everybody an idea. So if you're curious about this new feature that Octopus just rolled out around ephemeral environments, or you've been trying to do something similar, know now that it's much easier to set up an Octopus, and it's really nice having that in its own feature, so that you can interact with your ephemeral environments, and it's not cluttering up tenants, which I think I don't know for sure. You could ask some of the other folks on this call, but I'm pretty sure tenants were intended for different customers, multi-tenanted deployments, not for multiple test environments. We just used it for that because it was convenient for solving this challenge. But now that we have ephemeral environments built in, we can just do that. So you can see all of your test environments in a separate section in the Octopus Deploy portal. And if you're thinking about doing it, I'm happy to answer any questions about what we've done with Testry. I'm sure you can reach out to David as well. If you scan this QR code, I think it just takes you to my LinkedIn profile. I always love fielding questions from folks. So if you feel like something didn't get answered here today, go ahead and connect with me on LinkedIn. Let me know this is where we connected from and what you're interested in chatting about. But happy to help you set up Octopus Deploy to run Testry tests in ephemeral environments so that you can see the same results David here shared with us today. And if you haven't had your first 100% green test run, I'm the guy to get you there. And if you haven't had your first 10,000, you can talk to me and David, and we can both help you get there. So
I'm loving the confidence. This is wonderful.
Yeah.
Awesome stuff. Thank you very much, David and Chris. Great story. I had some folks ping me on the Slack. They're like, this is amazing. Look at the numbers. This is great. If you guys want to read more about ephemeral environments, you'll find it up on our What's New page, which you'll find at octopus.com/what's new. You can click the link there, read more about it. We've done a webinar about it as well, etc. So if you're curious about that, you can check it out there. Chris and David, thank you very much for speaking at Shipped. We really appreciate it.
Awesome. Yeah, thank you for having us.
All right. Oh, sorry, cut them off there. That always happens. I say thank you, and then they're about to say goodbye, and then I cut them off. I apologize. Sorry about that. All right, so let's get back to the schedule. Apologies if some folks are having trouble joining the second stream. We're doing our best. We've got 2 streams, obviously. We cut one off, and then we added this one. But coming up next is no stranger to Octopus Deploy. Jeffrey Palermo is a very well-known member of the community. He's going to do a talk here on AI architecture, .NET, specifically AI architecture and DevOps. And Jeffrey will cover, the architectural impact of introducing large language models into .NET systems. Always an interesting sort of decision there. So we'll add Jeffrey here to the stage. And there he is. Jeffrey, how's it going?
I'm doing great. Glad to be here.
Yeah, thanks for joining. Really appreciate it. Let's go ahead and get your slides queued up if you have any or any demos. And
I will.
You're fine.
Share the screen here.
The wonders of technology. I love it. Fantastic. And we'll get you to click that hide button there, and then I think the stage is yours.
Yep, there we go. Hide.
Awesome. Thanks.
All right, thank you very much. Great to be here. Welcome everyone. I'm excited to focus on .NET AI architecture and DevOps, and to come back to the SHIPPED conference. So we've got a lot to cover and a short time to cover it in, and so I'm gonna get right into it. I've been working on DevOps since. Well, I'll go all the way back to 2005 with continuous integration. I know that the term wasn't coined until sometime later, but the overall premise is that we need to be able to make changes quickly, and we need to know that we haven't broken anything, keep everything high quality, and we need to know when we deploy out to various environments and to production with our customers that our system is stable. It's one thing to be not finished with the next feature, but we absolutely must know that the software is still doing everything that we're counting on it doing. Okay, so a quick agenda as we run through. I'm going to talk about AI-driven development a little bit. Then I'm going to talk about the architecture of an Octopus-powered pipeline when you are employing AI-driven development, and then I'll weave in some the DevOps principles and practices for AI-enabled systems. Now, just right at a year ago, I published my 5th book, and this one's called The 5 Pillars: Leadership for Effective Custom Software. And if you want to use that QR code, do a screenshot, put your smartphone up to it, I'd be happy to get you a free electronic copy of the book. You can also go on audible.com if you like audiobooks, or Amazon for print books, hardcover and softcover, as well as ebook in the Amazon Kindle store. So you can do all those things. All right, I do want to call your attention to the DORA State of AI-Assisted Software Development report for 2025, and Octopus Deploy is one of the gold sponsors for that report. And I'm just going to pull up a little bit of what was in that report. Now, this is 2025. There's also some reports from 2024. But if we remember correctly, Cursor came out at the end of 2025, and Copilot came out in May. And of course, you've got Claude, and you've got JetBrains Junie, and so many more, and then the open source tool. And there's been some interesting findings. The organizational performance has increased by 10%. Valuable work has increased by 8%. Code quality has increased by 7%. Product performance, the blue dots above 0, those are all good things. The amount of burnout or friction in software development hasn't really changed much. Those are hovering very close to 0. So that hasn't changed much. But I do want to call your attention to the software delivery instability. That means that the instability of software delivery for teams using AI coding tools has increased 10%. That's right. That's a bad thing. 10% more instability or 10% less stability for teams that are trying to generate code with AI. That's here in 2025. And I'm going to talk about how you can not be in that group losing 10% of your stability and as we go forward, because we absolutely want the better organizational performance. We want to be able to do more valuable work. We want code quality, but we want our software systems to remain rock steady. Okay, I've used this over the years. And by the way, I know there's a lot of small text here. I'm not going to go through everything. If anyone would like a high resolution PDF of this DevOps architecture poster, just send me an email or LinkedIn, and I'll be happy to get one to you, or use that QR code as well. And the architecture, this one does call out Azure DevOps, but actually in the demo today, I'm going to use GitHub Actions paired with Octopus Deploy for a pipeline. And I just want to stress that you can't properly have a complete DevOps environment if you don't fully implement continuous integration. And I'll touch on why later. But you'll see that we have a private build, we have an integration build, and we have our automatic first deployment of our software to a test automation environment using Octopus Deploy, and then using GitHub Actions to run full system acceptance tests. Okay. Now, before I go into the actual demo and how everything is stitched together, I'm actually going to pop out of the slides, and I'm going to start a Copilot coding agent going to develop a feature for me. Okay, so I'm going to let's see, the right one here is, okay, I have an issue in GitHub. There it is. I have an issue in GitHub, and we are going to add work order instructions to an application. Now, what application, you might say? I'm going to actually Control F5. Actually, no, I already have it up on the test automation environment. And this is a church work order management system for the First Church of Springfield, if anyone remembers The Simpsons. And I'm logged in as the Reverend Timothy Lovejoy. And I can create a work order, and I can assign it to someone who works at the church. I can give it a title in the description. And I want to add an instructions field right here, description, between description and what room number of the church. I want to add an instructions field, a text area, kind of like description, so that we can add work order instructions. That's a pretty simple feature, right? But we should be able to use AI to develop simple features where we already have the patterns. So I already have this feature that I've assigned to Copilot, but I'm gonna do this again. So I'm actually going to copy all of this text and get this guy going. So what I'm going to do is I'm going to create a brand new issue, and I'm going to say Octopus shipped add instructions field. All right, I'm just going to get this going. We're not going to sit here and watch it the whole time, but I'm going to paste it in. I'm going to paste it in, and of course, don't reuse any existing branch from master, GitHub coding agent, and I'm going to say put Octopus dash. Okay, and let's go ahead and create that issue, and then I'm going to assign it to Copilot. And when I assign it to Copilot, I can add some more things like make sure to run private build.ps1 and acceptance test.ps1. Now, these are things you'd put in your Copilot instructions for standardization, but you can add additional things there. So let me just assign it, and that's going to get it going. And you know that the coding agent is working behind the scenes because you're going to see a little eyeball. There we go, a little eyeball. Now, this is running on GitHub's servers on a Linux VM. If I want to run it locally, I can, and I'm going to show running it on Claude, or what it looks like to run on Claude, Cursor, and GitHub Copilot later. But I just want to get this new guy going. Now, you might ask, well, all this text, that's a lot of information. Well, we want to automate as much as possible. So I'm going to go over to my Microsoft 365 Copilot, and I have a product management agent. And I'm just going to talk about this. So let's see, I'm going to hit Windows H, and let's see if we can't create a good descriptive GitHub issue really quickly. Microphone starts up. In my work order application, I need to be able to specify instructions when creating the work order. So what I want to do is on the new work order screen, we need a new field named instructions, and I want it to go below description, above the room number, and I want to support up to 4,000 characters. Let's use nvarchar 4000 in the SQL Server database. So we'll need a new database migration script. We should be able to modify the same Blazor screen. From a test scenarios perspective, this is an optional field. So I want to be able to create the work order without instructions and go back to an existing work order and add instructions later. I also want to be able to create a new work order and specify the instructions right off the bat. And I want to be able to come to an existing work order that doesn't have any instructions and then add the instructions into it. Those are the 3 different test scenarios. Oh, one more test scenario. Make it 4 test scenarios. Make sure that I can add all 4,000 characters into that instructions field. Now give me a descriptive GitHub issue ready to go. All right, just hit the enter key, and I'm going to hit go. All right, and here we go. What we can see is here's my title, add instructions field to work order and database. Here's the description, and it's basically organizing everything, my conceptual requirements, my technical details, my test scenarios and acceptance criteria. Okay, so and what you saw was I had a lot of text here. Okay, I'm going to go back and I'm going to edit, and everybody should be using agents. This is an agent that I created for myself, and you're an agent that helps people analyze software features. Now, I have some instructions about the system that I'm working on, but I've also put in the entire manuscript of my software leadership book, which talks about the 4 different design decisions that we need to specify and call out for every feature before we start on the code. So that's kind of what I've done, and I encourage you all to be creating agents for your organization. All right, so at this point, we have a draft pull request going. The Copilot agent has its checklist, and it's going to town. You can sit here and watch this if you want, and you can view what it's doing, and you can see that it's looked at all these files in the code base, and now it's doing some edits. It's editing the work order map. So if we scroll it down, we can see that it's added line 23 in the entity framework mapping. Okay, I'm not going to hover here, but I just wanted to get this guy going and then come back to our PowerPoint. Okay, so now I'm back in PowerPoint, and I want to show you how we're stitching together GitHub Actions with Octopus Deploy for a complete DevOps environment when doing AI-driven development. So this is the architecture of an AI DevOps environment. So everyone's hopefully familiar with integration builds at this point. And so this is what it looks like in GitHub Actions to have your integration build. And we want to have our integration build going against master, but also against every feature branch, whether it's a feature branch that Copilot's working on, or it's a feature branch that I'm working on myself. I want the benefit of my integration build so that I know that if I push something and the build is running on a box that's not mine, I want to make sure that I know that I didn't break anything. All right, now let's go to the next concept. This is the GitHub Actions pipeline. So I have 5 jobs: the integration build, then publish the release candidate, then the TDD environment, which stands for test-driven development. That's the name the acronym I like for my test automation environments. Then UAT, user acceptance testing, and then production. In any kind of deployment pipeline, you need at least 3 environments because there's 3 categories of environments. We all know production, you need at least one of those. Some people, you might need multiple production environments. Some people have, production per customer. That's what the Octopus Deploy tenancy feature is great at. Then pulling back from that, we need our manual test environment. We need at least one of those, but a lot of teams need multiple for different audiences. Then pulling back from that, we need a test automation environment. This is where we run our full system acceptance tests. And that answers the question, when I take this new build, this new release candidate, and I deploy it to Azure or wherever I'm deploying it to, and I'm deploying to the real environment, does it actually start up? Does it connect to the database and other resources that it has? Does it still do what it did before, and do all of my full system acceptance tests pass? Because I can run the private build locally on my workstation, and that could pass. I could run the integration build mixed with the code of my team members on the build server, and that could pass and be just fine. But if I don't have an application component pointed to the right connection string for the database in that environment, I could be completely broken. And an Octopus Deploy, which I'll forward to next, this is the same project, and GitHub Actions maps on top of this particular pipeline, and Octopus Deploy will deploy my Azure Container App and will run DB up against my SQL Server database. And those all things will be fine. But until I actually do some type of test, I don't have the feedback. And it's one thing to do a health check. Am I connected? That's great. But I need to run my ever-growing full system acceptance test against the deployed environment. So there's really 2 styles. The getting started style of a DevOps environment is to just be sequential. And you have a couple options. If you want visibility from your build server, which in this case is GitHub Actions or TeamCity or Azure Pipelines, then you kind of map stages and then you delegate to Octopus Deploy. That's your getting started stage. But what ends up happening is that you end up having multiple UAT environments and multiple production environments, and you have more complicated life cycles that the build servers don't support. And so then what happens is you end up just doing your integration build and publishing, and then you hand off to Octopus, and then you're doing your deployments using the Octopus Deploy dashboard. And then you have your run books that are sizing up environments and sizing it down and restarting services. So just for context, if I jump into this particular process, just to show you, it's as simple as it gets. The TDD UAT prod lifecycle, and these are the steps for deploying this particular application. We just upgraded this application to .NET 10, and we are opening Azure SQL, the firewall, so that we can actually run from an Octopus worker. We're opening the firewall at the beginning and then closing the firewall at the end so that we don't leave a perpetual firewall rule available outside of Azure. And then we run DB up. We run the database migration, which is inside of a PowerShell file. And then we add a revision to our container app, and that's it. And so as we come back, when we run this, we can see that all of our stages pass. And I'm going to show you a few other details before I go back to the interactive demo. When I am inside my YAML file for a GitHub action, for those of you who have never used GitHub Actions before, there are there's 2 steps that are really important for the test automation environment. And one of them is to deploy the actual release. So we created the release, but now we're actually going to deploy to the TDD environment. And so we're going to use the deploy release action that's provided by Octopus. We're going to give it some environment variables and the release number. So you have to have full traceability. So if my release is 1.3.777, if that's my new build, well, I want to call that release in Octopus Deploy the exact same thing, 1.3.777. And so adopt semantic versioning, and whether you have 3 number versions or if you have 4 number versions, use the same thing on your build server as you do in Octopus Deploy, so you have absolute good traceability. Okay, so we are going to deploy. Then we are going to use the await task action, and this is in the V3 of the APIs, and we are going to wait until the TDD environment completes. Why? Because we need to run a test suite against the deployed TDD environment with that new release candidate. And so the deploy release action, that returns immediately, okay? If we tried to run tests right after this, well, Octopus Deploy isn't quite finished. And so we use the await task action to cause GitHub Actions to wait for Octopus Deploy to finish doing that deployment. And now we have a deployed application where we can run our tests against. Okay. Now, I have delegated one feature to the computer, but I want to go over a survey of all of these coding tools and some of the important differences so that you can be aware of that and you can enhance the architecture of your DevOps environment for AI. Okay. And Cursor, it's one of the first movers in our industry. We have Cursor, we have VS Code with Copilot, we have Visual Studio with Copilot, we have Claude.ai, which is actually in a web browser. We have Claude Code CLI, which is on my local workstation. We have JetBrains Writer with Junie. We have the GitHub Copilot Coding Agent, which now has amassed an acronym, CCA, because nobody wants to say Copilot Coding Agent. And then we have the GitHub Claude Agent, which is provided by Claude, and it runs as a GitHub action. And then we have the Claude Code iPhone app, which you can literally start and delegate a feature on your iPhone. And then we have Open Code, which is an open source tool similar to Claude Code CLI, and it runs on the local workstation. So I want you to pay special attention to where this actually runs, the execution environment. And notice that some of them run on my workstation, the local workstation. VS Code, Copilot, Visual Studio with Copilot. When it's running on my computer, I'm running Windows. And if it's running on my computer, then it's running Windows. It has everything necessary for it. But look at the ones where the operating system is Linux. Claude.ai, GitHub Copilot Coding Agent, Claude Code Agent, Claude Code iPhone. Those are running on Linux VMs. And the one that I just kicked off at the beginning of this presentation was the Copilot Coding Agent. All right, that is running on a Linux VM. Now, it's really important to analyze your particular environment, because chances are, if every bit of your DevOps automation has run on Windows computers, and now you want to take advantage of AI-driven development, you're on GitHub, you're going to want to use some of the Linux-based AI coding tools like CCA and like Claude Agent, and those are running on Linux. So you're going to have to go through your PowerShell scripts and all of your automation and your build chain and your testing. And while .NET 10 is fully Linux compatible, some of the commands in our build scripts aren't necessarily, if we haven't run. Chances are there's going to be something that kind of assumes it's being run on Windows and isn't Linux compatible. So you're going to have to go through that exercise, but I want to stress to you why. Okay, so let's come back. Let's pop out of PowerPoint now, and let's come back to the GitHub Coding Agent. So I'm going to just do a quick refresh on here, the one that I just ran against. All right, so if I go all the way up, there we go. We've got the GitHub MCP server and the Playwright MCP server so that the coding agent can fully use GitHub. And if we go down, we can see, yes, it made a bunch of changes. That's all fine. And you can do that inside Visual Studio. But if we go down further, and I want to make sure that this is finished yet, because if it's not finished, we'll go to one that's already finished, because it does take a while. Bash install, fix it. Run acceptance test to validate full. Okay, here we go. And after fixing testing, there we go. Okay, inside here, if I scroll down, all right, let me scroll up to the top. we've been making changes, right? We're viewing some code, and we're actually creating a new acceptance test. So part of the work to create this feature is actually to create a new test. And I'm going to call your attention to the next. Now let's run the private build to validate our changes. Okay, what does that simulate? Well, if I was running, and I have if you check out my code, it's public. It's just that URL that you see, github.com/clearmeasurelabs/bootcamp-palermo.work orders. And I have a helper function called private-build.ps1, and I have a batch file, a clickable batch file that just runs it. So if I'm making a change locally, I'm going to run my private build because I want to quickly rebuild, recreate my local database, because chances are I've made a change to my local database. I want to run my unit tests. I want to run my integration tests, any kind of quick static analysis, whatever is appropriate, whatever is in your private build. And looks like I have the application running, but we'll see if that matters. But this is the script, and I'm going to run this locally a lot before I commit and even start thinking about a pull request, because it keeps me safe locally. So if I'm going to run this script for myself, and it's going to build, and it's going to run unit tests, and it's going to run integration tests. So build succeeded. Yeah, 39. And by the way, we just upgraded to .NET 10. Coverlet collector has an incompatibility with .NET 10, and so that's what that is. But we have private build succeeded. There we go, right there. And so if I run it locally, anytime code is going to change, I need that same continuous integration asset to be runnable by any of the coding agents that I have under my supervision. Okay. So in my instructions, we have a PowerShell helper that we can run. And so this is the running of the private build. So I'm going to call your attention to it's pulling. Yep. So you can see some of the projects, data access, UI.client, creating some DLLs. It's doing some compilation, and the build failed the first time. Okay. So it failed, and it's, find the correct command for assign. So the private build fed into Copilot Coding Agent because it wasn't quite ready. And so it's going to keep on working. All right. So, and then it's going to run the private build again. So let's see what happened with this private build. Let's scroll down, and okay, now it all compiled just fine. At this, we have 39 unit tests that passed. There's the code coverage from the unit tests, and restoring up settings, Bolton. Okay. And okay, the private build succeeded this time. So that was a good feedback loop, because Copilot Coding Agent did some edits like all these coding tools do. And then sometimes they report success, like, okay, I did everything, success. Well, how do we know if it's ready for me to look at? If it's a waste of my time, if it's not actually finished. And the definition of finished, we figured that's out a long time ago with the 3 stages of continuous integration under our DevOps umbrella. That's why we have our private build. That is the definition of, well, I've done something locally and it's good, and I should commit it because I'm at least as stable as I was when I started. And so we have to take that DevOps asset and make it available to the AI tools that we're using in our environment. And so that's the private build. And then the next one is, okay, now let me commit this fix and run the acceptance tests. And so now I have a PowerShell script that runs the full system acceptance tests. And to do that, Playwright has to be installed. Okay, that's all great. Let's run the acceptance tests. And let's see if any of them failed. And well, this is really compiling. Starting test executions, 14. Stop bash to stop. The tests are running, waiting for the output. Okay. And then finally, yeah, so there's a lot of these logs as it ran a lot of tests. Okay, there's the test coverage from the full system acceptance test. 31 passed, 0 failed. That's very good. Okay, so now 31 acceptance tests passed, and now I can move on. Let's see. And so preview, what's it doing now? It's doing the instructions field is properly. Review changes. Okay, run code quality. So it's still working. Why do we need to run the full system acceptance tests? Well, while I'm talking, why don't I go ahead and just kick them off for you? So this is locally, I have a in-unit test suite, and these are playwright tests. And if you've never seen a playwright test, then let me just actually the authentication. That's the easiest one. The authentication, I'm going to make sure that there is a user. That's my setup, verifying the setup. And then here's a test. Log in with username only, and it forwards to the home page. So I'm going to go to my home page. I'm going to wait for it to load. And I always like to take screenshots because when it fails, that helps. It really helps to see what it looked like when it failed. Okay. And just to make this test repeatable, we are going to click the logout link to make sure we're logged out if we're doing things before it. Then I'm going to find the login link, and I'm going to click that, and then I'm going to select the user H Simpson, and then I'm going to click the login button, and then I'm going to expect that there is text on the screen that says welcome H Simpson. Now, how do we get login link.elements? Where does this come from? I'm going to hit Control B. I'm just going to go to this, and there's a paradigm, a pattern about putting in compilable assets. And if we look, this is, by the way, this is the login link.razor. This is a very small Blazor component. Look how small it is. It is only an anchor tag. Okay. And we have the data-test ID set to the text of elements login link. And we have that specified here. And so we have a handle, we have a strongly typed handle for any test where we need to get it. All right, so that's what it looks like. But if I were to run it, let's just right click and run with ReSharper. This is what Copilot is able to do when you intentionally make your DevOps assets runnable. And then, of course, put it in your Copilot instructions. And this works whether or not you're actually. I need to get rid of those. Yeah, I need to stop. I need to stop the. I was running it previously. Okay. Hold on a second. Let me get rid of. Sometimes have these .NET hosts that hang around. And which one is it? In task. Some of these hang around because I've been doing it so many times. So let me just do a real quick cleanup. And I've been meaning to create a PowerShell script for this, but. Okay, so I hit Control-Shift-B. Starting. Okay, so now I can right click and I can run my acceptance tests. Okay, so this is just the regular old in-unit test, but I have in my helper, my acceptance test base, I have set the headless to be false because I want the test to pop up. Now, you can see me on the screen. My hands are up in the air. I'm not doing anything. And this is Playwright. These are about 31 of these tests. And it's popping open a browser and it's logging in. It's doing something, all the different test scenarios. Sometimes I log in. Sometimes I create a work order. Sometimes I do a search. And so sometimes they're quick. Sometimes it's one or two steps. They progressively get more expansive, like even typing in text boxes, searching. And you can see, if your eyes are pretty quick, that we already have the instructions field on here because we run this locally. And so these are the full system tests. And I know probably some of you listening don't have a completely automated set of full system tests in your software. You need them. That is an absolute required DevOps asset when you really want to move fast. Okay, you've got Octopus Deploy. You can deploy new versions of the code really, really quickly. but you do not want to deploy bugs to your customers really, really quickly. And so you need this asset integrated into the right place in your DevOps environment so that you can always have the answer to the question, with what I just did, with the code that just changed, not only will the application still start up, but does every scenario of behavior that has been working in the application up to this point, does it still work? Okay. So we've got our full system acceptance tests. And what's really important is that this full test suite, you're probably used to having it Windows compatible. This full test suite needs to be Linux compatible. Now, .NET 10, yep, no problem, Linux compatible. Playwright, no problem, Linux compatible. InUnit, XUnit, no problem, Linux compatible. But it's about how you put together the scripts and the glue and the sequence of events, because I have to have, in whatever environment I'm running this test suite in, I have to spin up the web application so that when I go to the browser, there's something running locally on a certain port. And I have to spin up and make sure I have a local SQL Server database and whatever dependencies the application has. And if my application has multiple websites, or a web application, a public one, and then a backend admin only web application, and then a web service API web application, and then a backend job, or a couple of service workers, all those things need to be spun up and active so that I can run this suite of full system tests. Okay. And I'm just running on the screen. This is a very, very powerful suite of tests, because if there was anything messed up in the code where adding this instructions field caused something that was working before to not work, well, then I would find out right away, and I would know that something is hosed on that feature branch. That is very, very important feedback to get, because if you allocate something simple like this and you think, you know what, let me delegate it to the computer, let me give it to one of these coding agents and just set it aside, and let me go off and let me do something else. Let me work on a complicated feature, or maybe the next architectural enhancement to the system. Let me focus my brain on that while the computer is working on something easy, like just adding a new field. That's super easy. Then when the computer reports success status, just like Octopus, when Octopus deploys, when it reports successful deployment, we need to have it set up so that it really means that everything was successful and I'm ready to go. So when the Copilot coding agent reports success, it really needs to be success. It needs to be that, yep, this enhancement has been made, and the software is stable, and all previous tests pass, and that new tests that are there pass as well. So it looks like the coding agent that we started at the beginning of the presentation has now completely finished. Yeah, completely finished. So instructions field, there it is, supports up to 4,000 characters. And then we can look at the code that has changed. So we can also see that it created some brand new full system acceptance tests, because I have a pretty robust Copilot instructions file. So it's creating new unit tests, it's creating new integration tests, and it's creating new full system acceptance tests. And I can look and I can make sure now in my pull request, the pull request is actually useful, because I'm not wondering if my code base is hosed. I'm not wondering if something is broken. I'm actually looking and saying, okay, am I happy submitting this code as mine to my team? This is business equipment. The Copilot coding agent, whether you use that or Cursor or Claude or any of them, yes, it's helping us do things faster, but they are my tools. And it is up to me to submit my code changes to my team. And there's nothing more disrespectful than for me to submit code to my team and say, I don't know if this is good. The computer kind of did this code anyway, so somebody let me know if it's good. No, that's so disrespectful. You'd never copy just large swaths of code off of Stack Overflow and just paste it into a Git commit and then send it off to your team with that mindset. No, if I am going to make a commit to the code base, or if I am going to submit a pull request to my team, that is my code. It doesn't matter what tools I used to get it there, whether it was just basic IntelliSense to help, fill in some blanks, or ReSharper to do some of the smaller blocks, or if I use more powerful tools to generate even more. That is my code, my responsibility. And so now I can look through and I can see, am I happy with it? Does it follow my patterns? So as I close up here, I go back to the slides. I want to call your attention to all of these options, and some of these and more are going to be on Linux. So you need to have all of your DevOps assets. You need to enhance the architecture so that they run equally well on Linux as well as Windows. And that's going to open up and make available to your coding agents all of your DevOps assets, so that when you're ready to go to a pull request, it's what you want. All right, I'm including some screenshots. This is Cursor, and this is what Cursor looks like when it's finished with a feature. Just see, if you've never used Cursor, this is what it looks like. It's a fork of the VS Code code base, and you can have multiple agents. It uses a Git working trees so that you can actually have multiple feature branches going at once, and you can have lots and lots of different features being worked on your computer. Now, if you're going to run multiple coding agents on your computer, and they're all going to be running your private build, and you're all going to be running these tests, then your test suites and your local environment need to be parallelizable, so that one instance of a running private build or acceptance test doesn't change your local database or change something that causes another run of it to fail. So that's another thing to think about if you're going to have multiple of these running on your computer. All right. This is what GitHub Copilot looks like in Visual Studio. You're probably the most familiar with that. This is JetBrains Junie. This is Rider. This is JetBrains Rider with Junie Pro. And what I like about this is on the right-hand side, you have the rundown of what it's doing. And then in the middle pane, it has the overall plan that it's kind of working down. So that's an interesting touch that JetBrains puts in. All right. And this is Claude CLI. This is in the terminal, completely command line. And I've actually been using Claude CLI, and now Copilot CLI is in preview, but I've been using Code CLI a lot just in environment cleanup. For example, I create lots of databases locally. I'll say, hey, all of the databases named such and such, delete those databases locally. And it's slinging PowerShell for me and saving me a lot of time. I've even used Claude CLI to increase my screen brightness on my laptop, because it can run any command line. All right, and this is what the Claude agent in GitHub looks like. All right, when you delegate this type of feature to it, and this is what Claude Code.ai looks like in the web browser, and this is in a constrained Linux container, so it can generate. It does not have the ability to have the feedback loop because it cannot run commands. It can't run .NET.exe. It cannot run PowerShell scripts. And so this is the least powerful of all of the available configurations. And I mentioned running. I mentioned having the ability to run multiple instances of your builds in parallel, and you can see we put timestamps in all of the instances of the databases that we create, so that we can have multiple local databases that don't conflict with each other. All right. So as you enhance the architecture of your DevOps environment, you're going to want to support Linux. That's an important thing. But I'm going to leave you with a final exhortation when enhancing that DevOps environment with AI. Some of the tried and true principles still apply. If you have a progression of environments from test automation environment to manual testing environments to production environments, by the time you deploy to production, you want to be doing very, very little. You want to do a lot in upstream environments, so that by the time you deploy to production, you have done everything else before. Everything has been tested. You don't want to do anything for the first time in production. You want to make your first deployment very, very rigorous. because you are squeezing out these bugs. All right, I'll leave you with that, and leave you with this QR code. If you'd like this book, the PDF copy that we send, you can. It's a text PDF, so you can take that and use the text of the book to make a Microsoft 365 product management agent that will help you really, really quickly create robust product backlog items or GitHub issues, wherever you store your work, and help fill in the blanks so that you can just turn on your microphone, Windows H hotkey, and just start talking about what kind of feature, or even equip your analysts or equip other people at your company with an internal company agent where you just speak in what you want the software to do and have the software help format it. So you can use that QR code to request the book, and then use that PDF, use the text of the book to power a agent to help you with feature specification. So thank you very much for coming to the Shipped conference with Octopus Deploy, and this is always fun, and this is a very, very great audience, and you guys who are using DevOps automation powered by Octopus are already a step above. So it's really encouraged by this community.
Awesome stuff. Thank you very much, Jeffrey. Great presentation. It's like watching the Whopper from War Games. I'm older, so in 1984, just watching the machine do all the stuff. Big fan of obviously the integrated test, which is great. Thank you very much for that presentation. It was wonderful to see all the innovation that's being done.
My pleasure. Thanks so much.
All right, so moving right along, folks, we're going to just go ahead and get right into the next session. I know that we're got one more session between this session we're doing right now and the next break. So what we're going to do is just get things set up here on our end. But coming up next, we've got Piotr, who's going to do a session on flexible Kubernetes multi-tenancy with vCluster, which is, if you haven't used vCluster, it's like a lightweight virtual cluster layer that runs inside of Kubernetes. And we'll just go ahead and add Piotr to the screen here. Hi, how are you?
Hi, John. Doing great. Thank you for inviting me. Super excited to be here.
Thank you for speaking. Really appreciate it. You spoke last year at SHIPPED25, and we thought it would be great to have you again. So
Awesome.
Do you have any slides that you would like to share, or a desktop?
I would like to share my desktop. I'll have a terminal slides and some other demos. So,
all right, well, let's get you set up there.
Nice. Let me find button for sharing. Kubernetes is easy. Sharing stuff, that's hard, right? Okay. I think I got this. All right.
Okay, no worries.
So I hope you all can
It's amazing how
screen.
sharing screens are just impossible for tech people like us. All right. Thank you very much. The stage is yours.
Awesome. Thank you so much. All right. Hi, everyone. So as John mentioned, I work at vCluster. We are a company behind containerized Kubernetes, and we like Kubernetes so much that we put Kubernetes inside of Kubernetes. And you will see how cool is that later. The topic of my talk will be flexible multi-tenancy. And I would like to start with a kind of a promise, and hopefully at the end, you will see that what I promise makes sense. And I say that multi-tenancy nowadays is becoming slowly table stakes. Like in the old days, having a server was table stakes, or then having a domain and web page. Then slowly we are moving to a world where supporting multiple internal customers, maybe your teams, or external customers, maybe you're serving a SaaS or other products, is really critical. So this will be the topic of the talk. A little bit about me. My name is Piotr Zdaniewski. I work at vCluster as a head of engineering enablement. This is really platform engineering. We just thought that this name is more fancy. But I do operations predominantly in platform engineering. I've been running platform teams and been in the space for quite a while. I worked at Abound before, creators of Crossplane, and I've worked at Kubernetes in various areas. I like GitOps. I worked at SRE, so all that stuff. Been there, done that, and still enjoy the space. I do speaking engagements. You can snap this QR code and this will take you to my webpage where you can follow me on social media if you'd like, or just check out my other content. In my free time, I like working with NeoVim plugins. So if any of you like NeoVim, I have quite a lot of plugins I wrote and also videos about it. So yes, I am a NeoVim nerd. Lately, I started writing MCP servers for fun. Some of them became a little bit popular, so you can check out my GitHub profile if you're interested in this. All right, so what is tenancy or multi-tenancy? If you think about Kubernetes, I believe that it's nice to think of tenancy as a house. We all know a house. We either have one or more, and we live there. So if you live in a house or in an apartment, you definitely have neighbors. Hopefully, your neighbors are quiet, but not all the neighbors are quiet. So a single Kubernetes cluster, if you have teams or customers that run in the same cluster, that workloads run in the same cluster, it can be noisy, right? And in Kubernetes, this actually can lead to security problems, can lead to performance issues. So simply, there's a scenario where isolation is not really a first class citizen in Kubernetes. There is a mechanism in Kubernetes that you probably know if you've worked with it, called namespace. So namespaces is this basic mode where every team can have their own dedicated namespace and they can run their own workloads. But as we will see later, this has its own limitations. So this, courtesy of ChatGPT, obviously, picture shows us that the typical way of isolating workloads within Kubernetes is multi-tenancy, but we can do better. Now, is it really better? It depends how you look at it, but that's definitely how you can think of vCluster and its multi-tenancy. So suddenly, instead of having namespaces isolated just in this weak isolation level within your host cluster, you can actually have little Kubernetes clusters running within pods. So each of those windows represent a pod, and this big house is a host cluster. So that comes with all kinds of benefits. Isolation is immediately much better, and tenants don't actually interrupt each other and can still use all kinds of plumbing or electricity at the house. However, some of the tenants might have different needs than the others. Some of them might want more power or more privileges than the others, and we as platform teams or SREs might decide to do it. So we end up with this. This looks like a jumbled mess, but reality often is. And this actually shows us that every tenant can have and usually does have different needs. If you have supported your own teams within the Kubernetes cluster, you definitely will remember that maybe team starts on tier A of your internal platform, and then after a while they want something more. Some other team comes and they want a slight variation of what team A has, and it's never exactly a cookie cutter within the tenancy world. So we end up with scenarios where some of the tenants would use services that exist on the cluster. We call them shared services. Some of them would have their own plumbing with them. This picture doesn't really show it well, but imagine that you have water or electricity appliances on your own in your little home. So this messy reality is actually what we deal with. And vCluster is uniquely positioned to actually exactly work with this reality rather than with the cookie cutter marketing material where you have exact 10% this, 20% that. So how it works in practice, what vCluster really does. So the easiest thing to explain vCluster is that vCluster is a containerized Kubernetes inside the pod. Why on earth would anyone do it, right? So pods are the smallest deployable units within Kubernetes, and pod can run any number of containers. So vCluster takes advantage of this. And what we did is we took Kubernetes control plane. So if you're familiar with Kubernetes, this will be Kube API server, scheduler, and so on. And we placed those control plane elements, the control plane machinery, inside of a pod. And that gives us all kinds of interesting properties and benefits. We will dive into this a little bit later, but I want to show you what we can do. If you imagine Kubernetes from the perspective of the host cluster administrator, let's imagine that you are an EKS, working with EKS or GKE or Azure or on-prem. So you have a big host cluster. And within this host cluster, you might have several nodes. And then whether those are internal teams or external customers, they use your Kubernetes resources in various ways. Very often, as admins or platform engineers, we would have set of shared services. Think about cert manager, ingress controller, API gateway, service meshes like Istio, Falco for security, you name it. There's plenty of CNCF landscape projects we've all seen that you can install. Those shared services often require complicated configuration and maintenance. But what vCluster enables us to do, it enables us to create virtual clusters that either take those services and being themselves a completely isolated Kubernetes cluster can still use some of those shared services, or we can decide to actually place those shared services inside of vCluster, and then they become services unique to this virtual cluster that we elected to do. The obvious benefit from this is, of course, isolation and security, but also versioning. I can have ingress controller or API gateway version different on my host cluster and different in virtual cluster. So suddenly deploying of global resources is possible inside of virtual cluster. But if you haven't worked with virtual clusters, it might be a little bit confusing. So I'm going to try and show you and demystify a little bit how all this works and what can you do with it. So one more time, virtual cluster is a fully certified Kubernetes distribution. So like any other Kubernetes distribution that you can install anywhere, virtual cluster has all the components of Kubernetes, just with the difference that they are inside of a pod. Virtual cluster itself is quite small. It's very resource efficient. It's about 400 megabytes pod, and you can run them really easily, and you can have multiple of those, as we will see in a moment. All right, so we are going to use kind cluster. I cannot see all of you, but typically I would ask how many of you know kind cluster. If you don't, it is a really easy way to run Kubernetes locally. Kind cluster stands for Kubernetes in Docker. So nowadays, everybody has Docker. If you have Docker installed locally, you can super easily run Kubernetes on it. So that's what I did. I already created this kind cluster before. So once this kind cluster is deployed, we're going to proceed with the demo, but I want to stop and talk about another layer of multi-tenancy. So we talked about services isolation previously, so where we said that some services from the host cluster can be reused. Some of them can be dedicated to a specific team or a customer. The same can be said about security boundaries. Nowadays, I think it's extremely important to take security even more serious than we used to take, partially because of AI and more code coming our way, and this code is not always clean or high level. So having an ability to decide whether a certain team or workload has a high trust, zero trust, partial trust is very useful for platform teams. So we can dedicate certain zones within our host cluster where we can host or accommodate tenants that we assign to one of those security zones or isolation. So this is just another slider we can think about when we apply multi-tenancy in the real world. Earlier, we talked about shared services versus isolation. And then we have another slider, which gives us the ability to trust or not trust certain tenants or workloads within the tenant. So let's see what we're working with. I have here 2 nodes, and I just labeled them for the purposes of the demo. So we have 132 Kubernetes cluster running within my kind cluster, and this all works on my computer. Let's hope the demo will be quite okay. I want to install Nginx, and I will show you what's happening within the cluster. So I'm going to swap quickly to a different terminal. Write K9s. Again, if you know K9s, then you know it is awesome. If you don't and you work with Kubernetes, I highly recommend this program. As you see, it is a terminal-based Kubernetes viewer. You can interact with your cluster, and I'm going to use it to show you what's happening. So nothing interesting here. We just installed Nginx controller. That will be useful for our demo later. For now, we have our kind cluster called vCluster multi-tenancy, and we have a typical resources here. It's a fresh cluster, haven't done anything with it yet. All right, so this is done. Let's talk more specifically about the challenges that come from using namespaces. If you're using namespaces, what namespace is essentially a weak isolation boundary within Kubernetes that allows you to segregate resources into the namespaces. Things like pods, services, and other base Kubernetes resources can be namespace based. And this works in many cases. It's very quick to create a namespace and it's very fast to spin up one or delete. However, it comes with a lot of limitations. First of all, we have a shared API server. So everyone connecting to our namespace connects to the same Kubernetes API server and shares the same underlying data. Thus, the separation here already is weaker. This brings shared control plane risk. If control plane goes down, it goes down for everybody. And if control plane is corrupted for everybody. Another important limitation of namespaces, which if you work with Kubernetes, you definitely stumbled upon it, is the fact that namespaces do not support global objects such as CRDs. So if team A wants to have a different Istio version than team B, this is simply not possible with namespaces. And thus we fall into this trap of version locking. Now, one caveat here I want to make is that namespaces are not evil, far from it. They are very good tool if you just want to isolate workloads. If you're isolating pods and you have teams that only separate workloads and you don't need anything else, fantastic. That's a great solution. However, in reality, as we've learned at the beginning, reality is messy, and then you will quickly stumble upon a problem where the teams want a little bit more, a little bit extra. So if teams want a little bit extra, what can we do? Enter vCluster. So what we are doing here, I'm going to let it run first, and we're going to talk through what's happening. So here, every vCluster supports YAML file with values. This is simply a Helm values pulled into a YAML version. Almost any resource in Kubernetes, as well as kind, by the way, supports configuration from YAML. So we follow the same principle in vCluster, and we use vCluster CLI to create a dedicated virtual cluster. So the virtual cluster we created is named dev team. We do not connect to it at the start, and we are using this dev values file to instruct the vCluster operator within our pod how we would like our virtual cluster to work. So let's swap real quick to our K9s, and you can see in the background here, we have a new pod. Notice that vCluster is actually pod. All of those resources here are pods. So this is not a CRD-based controller. It's actually a normal pod. And this comes with all kinds of benefits because you can treat it as any other pod in Kubernetes, meaning that your existing security posture, your existing observability tooling would work with any vCluster. So we have core DNS, which comes as part of virtual cluster, and we have the virtual cluster name we created ourselves. There is this little -0, and I cannot see you and chat, so usually I ask this question, why this is -0, and you can take a moment to think about it, but -0 simply is a stateful set. So vCluster by default comes in the form of stateful set and creates just those 2 pods on the disk. Okay, so far I hope it's pretty easy. We've created a pod. Now let's connect to this pod. So before we connect, I actually want to talk a little bit about why would we choose vCluster for multi-tenancy. So what does vCluster offer that is so good within multi-tenancy that we would like to consider it? So vCluster spans various areas, so to say. So we can focus on development, and if we have dev test environments, we can fully isolate them, which is really desirable. If you run Kubernetes in CI, you can spin multiple virtual clusters really quickly on your dedicated cluster and then just have your CI target those rather than create clusters ad hoc. In production, you can have resource quotas or separate services. There is also significantly more isolation than I am showing you now. I am focusing only on the open source virtual cluster. We have recently released quite a few exciting offerings for multi-tenancy specifically, such as private nodes and others. I'll be happy to chat about it later if you would like to dive deeper. But suffice to say, this moves us further towards isolated clusters. So think of having almost like a separate cluster where each virtual cluster can target its own set of nodes. We have data science capabilities. So if you're familiar with K-AI scheduler from NVIDIA, vCluster can run those workloads as well, and you can isolate AI inference or training time through this mechanism as well. And this is what a lot of our customers do as well. So think of providing a GPU capability to your customers and having vCluster as a foundational technology for multi-tenancy. And finally, you can also expose parts of your Kubernetes resources to third parties or external partners like consultants maybe, or you have security audit or compliance. And we will see this in a moment as well. So let's connect to our cluster. So what's happening now, I am doing this locally. So vCluster is creating a proxy, enabling me to connect to my Kubernetes cluster. So let's see how this works. When we swap back, I'm going to restart K9S. You will notice that now we are in different virtual clusters. So we are here. Previously, we were in the kind cluster, and now we are in this long name context and long name cluster. So the pod that we have seen earlier with this dev team -0 has its own kube API running. And you can see here, we have this core DNS pod. So now I am connected to my virtual cluster. And from my perspective, as a customer or a team member that we support, this looks like regular cluster. I don't see any other pods or any other resources for the matter that are running downstream on my host cluster. I just see what my kube API server shows me. So this level of isolation means that I can interact with this cluster as if it were a regular Kubernetes cluster running in cloud or on-prem. So this is the level of isolation we are definitely after. So let's look what the vCluster pod has inside. So it has one init container, and you can see this is 134 Kubernetes, although our kind cluster is running 132. This is an interesting distinction for virtual cluster. We can run different Kubernetes versions in each virtual cluster. There's a SKU of versions supported, but we can upgrade and downgrade versions as we see fit for each tenant individually. So we have this init container that copied all the Kubernetes machinery, and we have a special container that we call syncer. Syncer is responsible for synchronizing resources between our virtual cluster and host cluster. What does it mean? Why does it synchronize anything? So you can see here that by default, virtual cluster keeps its resources inside of a database. In an open source virtual cluster, if you create one, go to our repository, install Helm chart, by default, you will get a SQLite, and the SQLite runs inside of a pod. So you mentioned earlier, we have API server, we have controller manager, we can have optionally scheduler, and we have our database. So this means that we have completely isolated little cluster that we can take, move around, and we can choose to synchronize various things between the host cluster it's running on and itself. So if this is possible, then this means we should be able to deploy something to it, right? So what I did is I deployed a web app. This is a super simple Nginx web app. And notice that we just did the deployment, we run it, it's done. And this deployment is running on our virtual cluster. So just to prove it to you, you can see now we have the web app here. This was previously not there. We are still connected to our virtual cluster. And if everything goes right and demo gods are with me, if I hit enter, this will work. Let's see. Okay, we are port forwarding. There you go. Kubernetes demo. We have a curl here. Let's see if we can open it in the browser. And this is a beautiful aggressive green, as I like to call it. So this works. This is fantastic. Okay. We were able to deploy a regular web app inside of a Kubernetes, inside of a Kubernetes. But this just goes to prove a point that this is regular Kubernetes cluster. Nothing different about it. It's just that from the perspective of my tenant, this just works, right? Okay, I mentioned earlier that our virtual cluster is fully encapsulated. And I want to show you that we can actually take it from our current host cluster. Remember, this is a kind cluster I'm running now. What I'm doing now is I'm snapshotting vCluster with its current state. If you don't know the service, TTL-SH, it's a super cool service that allows you to share OCI compliant artifacts like Docker images for free in an ephemeral way. So we have this little image that will expire within an hour. We snapshotted it, we send it to the internet, everything is great. Now we are going to create secondary kind cluster. We are emulating at this point that we maybe want to take our virtual cluster with all the data, with all the running state, and we want to clone it and transition it somewhere to maybe AKS or GKE or on-prem, right? It can be cloned and the old cluster can be deleted, or the cluster can be simply copied. All right, so let's create it. So you can see now I am creating the same cluster called dev-team. In this time, I'm using a restore flag, and I'm pointing to the same image in the TTL-SH service. So let's see if we are still lucky and our cluster works. Let me restart K9S. And if we are lucky, we are on kind host 2. We are. Today, it just works. Must be the conference. Fantastic. So we have kind host 2. And notice that our dev team vCluster is starting to be created. We have a special process that initializes the old settings and is essentially under the hood restoring the database and is reinitializing our dev team cluster 0. So this experience should be the same as we've had at the very beginning, where we created the virtual cluster first place. The difference is that now we are in a completely new host cluster. I probably should have named it like kind EKS and kind AKS, but that simulates this scenario. So now, finally, you can see we have our web app. It's right here. If this web app would have stayed with persistent volume, we could also choose to clone persistent volumes as well and to move them from one place to the other. Some of those things are enterprise features, some of those things are open source, but snapshotting vCluster like this is available for free as well. So you can take advantage of it. So once this is done and the container is going to be created, we should be able to interact with our web page in the same way like we did earlier. Let's see if this actually works. So this might take a moment because I've seen that the container is still created, but let's give it a try. Oh, we have to wait a little bit longer. Starting, forwarding, there we go. You can believe me that the same page is rendered now in completely different cluster. So that shows the power of what you can do with your virtual clusters. You can just take it from one host cluster and put it to another one. So let's delete this so my machine actually doesn't die in the meantime. So now this was kind of like a warm-up, and we are going to create another virtual cluster, this time for production. I'm going to go through this a little bit quicker due to time, but this just goes to show that now we can create a virtual cluster with different properties. So in this case, we are actually telling virtual cluster, create an ingress, so synchronize ingresses from virtual cluster to host, and synchronize nodes from host. I'm not going to explain all the settings. Our docs guide you through all the possible settings. There's quite a lot of them. So you can realize the promise that we talked about at the beginning, that you can actually slide the multi-tenancy sliders however you see fit. So this worked. Let's connect to our prod team. I'm going to swap real quick here. And as you can see, vCluster prod team. So we are now in another virtual cluster in the previous host cluster. This is, by the way, something you have to get used to or pay attention to, because it's a lot of swapping between clusters. If you're an administrator, you should better have your prompt annotated with what cluster you're currently on. Right, so we connected to it, and we are able to, in this case, I'm just showing you that we can actually expose the web app on our current DNS, and we can also see the actual node IP. You have to believe me that this is true because we can actually expose it to production team. Normally, this due to security settings, we do not expose the actual node IP to virtual cluster. And finally, a last quick demo with a feature that I really like. Imagine that you are a partner that collaborates with, or a partner company collaborates with your team, and you want to give them just a very limited access to your resources, but you still want to be able to onboard them to your Kubernetes cluster. And virtual cluster comes in handy. What we are doing here, we are saying every new virtual cluster created from this partner values file will have a config map and a secret. So you are using a templating system to create your virtual clusters with the special applications. This can, of course, be extended significantly. We have a dedicated templating system with permissions and application that helps you manage those things. But for the easy demo, we can definitely do this like that. So we're going to give it a moment to create and stabilize. And if everything is correct, we should be able to see this config map and secret when we connect to the partner team cluster. And we have a platform config, and we have a platform credentials secret. Let's see if this actually is here and I am not lying to you. So here we have a secret, platform credentials. And for those of you who are already excited about K9S, you can click X to decode our token. And I just leaked a token, partner ready token. There you go. Okay. So, of course, it's a test token. I didn't really leak it. All right, so now we have all those different clusters that we've created, and as a platform team or SREs, we were able to cater to various needs of various teams. So what were those needs? Let's summarize real quick. We have a dev team, production team or admin team, and a partner team. So the dev team was able to deploy pods within certain quotas. We did not allow them to exceed CPU or memory quotas across all their virtual clusters. Prod team, they are the lucky ones. They have an unlimited access. They can starve host cluster if they want to. Partner team were able to only deploy pods with certain tolerations, meaning that the pods that they would deploy would be deployed only to a specific nodes that virtual cluster targets. So we already from the get-go, we said even your pods, you can deploy them, but they're gonna land on a special fortified node. And we have also other ways within our product portfolio to make this security setting even tighter using products like vNode or other things. Services, our dev team was able to use only cluster IP services. Prod team, again, those guys can do whatever they want. And partner team couldn't deploy any services. If they would try to, they can deploy them, of course, inside the virtual cluster, but they cannot synchronize services between host cluster and virtual cluster. Same for ingresses. Dev team couldn't use it, prod team could, and partner team were not able to use it. Nodes, config maps, and resource limits. So as far as the sliders go, you can imagine that now fourth team comes in, and the team. Are you guys can hear me well? I'm not sure if my voice.
We can hear you fine. You're just sounds
perfect.
like your audio is starting to go. That's all.
Yeah, 98% CPU. You can see that my machine needs an upgrade. All right, so real quick, we have this fine-grained control over what crosses the boundary of virtual cluster and host cluster, right? And if you apply this to tens of tenants, cool. Hundreds of tenants, super cool. Thousands of tenants, well, now we're talking, right? You have ability to use infrastructure as code and GitOps to have your virtual clusters being deployed and managed to those tools. Remember, those are just Kubernetes pods at the end. And we also have a product called vCluster Platform, which enables you to manage your virtual clusters additionally at scale. I haven't talked about a lot of features that we also support. For instance, you can put virtual cluster into resources to sleep. If a team in different time zone finishes work, you can set hours where you save resources. So this gives us a way to bin pack as much resources as we can within a single cluster. So what can we see? We have those three virtual clusters running: dev team, partner team, and prod team. They are all running vCluster version 0.30.3. And now this is the namespaces where they run on. So really quickly, just to go over the benefits one more time. Our customers use vCluster in dev test environments. This was the original use case before we added more isolation. You can use it at GitHub CI. We use it to test in QA instead of creating clusters or using predefined cluster, which is create virtual clusters within our main host cluster and delete them afterwards. And this works really well. Tenant isolation, as we've seen, the sliders, I hope that kind of drove a point home that you can fit not only your current use cases, but also future use cases. If one team starts at one spectrum, they can gradually move to more secure or less secure or shared services and so on. Independent versioning, this is honestly my favorite. I know I'm boring probably, but I've done my share of updates and upgrades in Kubernetes, and the more the more tenants you support, well, the more stressful it becomes. Whereas with vCluster, you can choose to have shared services distributed independently, and then you can version each tenant independent. You can have a very small blast radius. You can test it on virtual cluster. So this is really fantastic feature and kind of helps SRE not have too much gray hair too early. Platform efficiency, mentioned about sleep earlier. There are also other features. A lot of them are obviously enterprise, but you can essentially save a lot of cost or support like high scale within the cluster itself. And finally, security boundaries. If you want to fortify your cluster, we have additional products such as vNode or other ways to kind of lock the isolation even more. So you can essentially choose to go from namespaces with very weak isolation to almost complete host clusters, but not quite. So you can have your own dedicated nodes for each virtual cluster. So we support this as well. You can visit our page, our docs, and learn all about it. So that's it. If we have time for any questions, we'll be happy to answer.
No, I don't think there were any questions that came through. That was awesome. I think you overloaded everyone with information, and so they're just kind of processing it. Awesome.
That's how it
stuff.
should be, right?
Yes, exactly.
Sometime in the evening, you were like, "Wow, that was so cool."
That's right. So I'm gonna have to watch this again. So don't forget, we're recording this and we're gonna post it up on YouTube. So you'll see a copy of the presentation there. Thank you so much. That was amazing. Once again, back to back, awesome presentations as part of Shipped. Thank you so much.
Thank you very much.
All right, folks. We're in the sort of last stages of Shipped here. We're in the home stretch, so we've got a break now. And then coming up, we've got the following 3 sessions. We've got T*D, 3 fundamental practices for high-performing teams. We've then got Spec to Ship, integrating GitHub Copilot and Octopus Deploy for AI-driven delivery. And then finally, Alex, lastly but not leastly, will be doing a talk on refactoring everything, everywhere, all at once. What a great way to end the conference. We're going to be back at approximately 20 minutes. So we've got 20 minutes past the hour. So 6:20 my time, star.20, whatever it is, your time. So 20 minutes past the hour, we will start up the stream once again, and you'll be able to obviously participate here.
Octopus software deployments were exciting. You got human error. One job. Ow! Late night emergency rollbacks.
All right, who is feeling alive?
Those were the days. And so much drama. And then Octopus came along, and now deployments are so boring. Now we have templates and runbooks. Everything is scalable, standardized, secure, compliant, and so easy.
I love him. He's doing well. Woo! My man. Let's go, bro. Let's do it.
Although, I would have time to join the hackathon.
We make deployments boring, so you can build extraordinary.
All right, everyone. We are... Oh, try and get this right. We are in the final stages of Shipped. I know it's been a long... Certainly it's been long for me. It's been super enjoyable, though. I've just been having to stay up all night. There you go, but that's okay. That's, that's kind of expected, I guess, if you're going to host these for different audiences. So just to kick things off, let's go ahead and share out the schedule as always. So we've got Andrea talking about 3 fundamental practices for high-performing teams. We've then got a session here on GitHub Copilot, and then Alex is going to wrap things up with refactoring. Let me go ahead and Andrea to the stage. Hello, how are you?
Hello, everyone. You can hear me okay, right? You can
Yes,
see my
absolutely. Yes, there are your slides. The floor is yours.
Oh, thank you very much. So my talk is going to be about this very weird thing that I call T-study. What I mean by that is nothing new, really. It's not practice that I created. But it's basically a way for me to say that these 3 practices, which I'm going to show you, should be used together to make teams high-performing. Before I delve into this, let me introduce myself. My name is Andrea Foggia. I'm a lead consulting engineer at Makuni. I've been a software engineer for 30 plus years, and I've been a coder for 40 plus years. As you can see from this picture, which was taken by my mom in 1984, and those were my dad's computers. My dad was a computer programmer, So he introduced me to this crazy world of programming. And the fun fact about those days is that whenever I had to tell my schoolmates what my dad did as a job, nobody would understand that, because they didn't understand what a programmer was, but they also didn't understand what a computer was. So that was the situation 40 years ago. So who are we? McKinney, we are a consultancy. We've been on the market for 12 years, very successful. We help companies embrace a high-performing culture. We promote what we call the AK way, which is this compendium of battle-tested engineering practices. And if you are curious about what we do, look at the playbook on our website. But to go back to T-STAR-D, it's basically the union, the magical mix of these three practices: trunk-based development, test-driven development, and what I call team-focused development, which is really mob programming. And I want to stress the point here that my idea is that in order for teams to be really, really high performing, these three practices should really go together, and I'll explain why. But before I delve into that, let me give you a definition of these practices, even though I'm sure many of you have heard of them before. So trunk-based development is fundamentally the idea that the whole team commits straight into shared mainline multiple times a day. Mainline is trunk or main or whatever we call it these days. If we use branches, those branches should be really short, really short-lived. And when I say short-lived, I mean that the age of the branch should ideally be hours, minutes, not days. Should be maximum 1 day in reality, but that should really be the worst case. And the whole point of this is that we keep changes flowing. Mainline stays healthy because it's exercised and tested and validated all the time. And this is really prerequisite for continuous integration. It makes continuous integration possible. If we don't do this, if we don't adopt trunk-based development, that is not continuous integration. If we branch off main and we go like that for days and days and days, committing, and then creating PR and then merging, that is not continuous integration. And I know what people say when I say this. They go like, oh, well, but we rebase main many times. Well, that is still not continuous integration. Continuous integration is literally going into trunk multiple times a day. Test-driven development, I'm pretty sure many people know about this. I'm just going to reiterate some basic concepts here. It's granular, incremental, and iterative way of working, where we write a failing test, then implement just the bare minimum code to make the test pass, and then we refactor that code to keep the design clean. It reduces risk, keeps changes manageable because they are very small, and nips problems in the bud. And it's a feedback loop at the smallest scale, really. If we are just unit testing, that is not necessarily test-driven development. Many people are confused about this. If you ask people for a definition of TDD, you'll have all sorts of different responses, and many of them will not align to the original definition of test-driven development. Many people are convinced that TDD is writing tests after, which is quite interesting. Team-focused development, also known as mob programming, also known as ensemble programming, software teaming. People call it different ways, but the idea is that the whole team works together on the same problem at the same time on the same code using a single workstation. We have very short feedback loops for design and architectures because the team communicates all the time, and it turns the design into a live collaborative process rather than a series of isolated, delayed reviews. Watching other people work is not team-focused development, because this is something I hear all the time by people who try to pair programming and tried mob programming. They say, well, it felt like someone was watching over my shoulders. That is not what pairing or mobbing means. And I want to stress the point that pairing and mobbing are two completely different activities. These concepts, these ideas are not new at all. As I said, I did not invent any of these practices. They are already there. There's plenty of books, a lot of literature about this stuff. This is just a very small subset of books, some of which are really, really old, but still very relevant, that I strongly suggest reading. But there's a lot more out there that is really worth reading. I want to go back to why I consider T-STAR-D a good thing, and why I think it should be a good thing for teams. It's because of this sentence that we find on Extreme Programming Explained. It's literally the first phrase that we find on the book. And it's quite powerful. It says the basic problem of software development is risk. And that's really true, right? When we implement software, that software can make people die. It can cause lots of damage. It can make airplane go down, right? We can cause really, really big problems. So how do we manage those problems? Well, as humans, we rely on feedback loops. So we do something, we observe what happens, we learn, we adapt, and then we repeat. And that's something we do all the time, right? We do it when we drive, when we walk down the shops, when we play sports, or we used to do it when we were hunting, elephants or mammoths in the old days. So what does it mean in software when we say we do? Well, we communicate ideas all the time. We implement those ideas. We integrate our ideas with other people's ideas. And we deliver our ideas to stakeholders, so someone for which those ideas are really important. So what kind of feedback are we expecting? We can communicate our ideas. Obviously, we want to know whether our ideas make sense. When we implement them, we want to know whether the implementation is valid, whether they integrate with other people's ideas correctly, and whether the stakeholders find our ideas valuable. And that's where I think T-STAR-D is really useful, because it provides compound feedback, right? It's nested loops that catch problems at the earliest possible moment. So we have the outer loop, which is trunk-based development, where we integrate and test, integrate and test, integrate and test, and in a cycle, and that keeps our software in a healthy state, ready to be delivered to production. And as long as that, we implement test-driven development, which is this cycle with this continuous stream of short-lived cycles, which are red phase, green phase, refactor, commit, red, green, refactor, commit all the time. And this should, in theory, last. These cycles should, in theory, last a few minutes. And at the foundation of all of this, there is team-focused development, which is basically a driver, navigators, and they switch roles all the time, and they keep communicating. So we all know that the longer it takes to get feedback, the higher the risk. And these practices really help reducing the time for these feedback. So trunk-based development provides minutes-level feedback on integration. Test-driven development provides seconds-level feedback on correctness. And team-focused development provides instant feedback on design and approach. And T-STAR-D really enables continuous delivery, which is a really important concept, the first principle in the Agile Manifesto, and very well explained in this book, which I highly recommend. It's quite old, but still very, very valuable book written by Jez Humble and David Farley. And how does these things link to the feedback that we want when we do something, right? Well, when we communicate our ideas, we want to see whether ideas make sense. And that's where team-focused development helps, because it's about the team working together, communicating, sharing things, and nipping problems in the bud at that very moment. When we implement our ideas, well, test-driven development allows us to granularize our problems into discrete behaviors and make sure that those behaviors reflect what we want from the system. And we could involve in that discussion many people from other areas, domain experts, and so on. We want to see whether our ideas integrate correctly, so the feedback is given by trunk-based development, which is effectively a prerequisite for continuous integration by keeping the system always healthy and integrating multiple times a day. And all of this brings to the final point, which is when we deliver the ideas to stakeholders, we want to see whether those ideas are valid, and continuous delivery is what allows us to do that. So T-STAR-D means true agility. We have tiny verified increments, so we work in small slices. We clarify intent before writing production code, which is really the core principle of Agile, where it says business people and development teams should be working together daily. We refactor continuously, which is a principle that comes from XP, really. We have fast feedback loops, so we reduce risk. And we learn and adapt, which is, again, a very important principle in Agile. And interestingly, this is a point that I always make. Many teams work with Scrum, and Scrum has some prescribed events that have to happen at a specific point in time, etc. And by adopting these practices, we can easily step up a bit and move to a point where we can probably ignore a lot of those events and embed them in the rhythm of the practice. So it's quite interesting for teams who adopt Scrum to look into these practices if they want to evolve. But is it everything so cool and hunky-dory? Where's the catch? So it's a very long and difficult journey to get there. To be able to implement all these practices correctly, it takes a time. It takes a long time, a lot of effort. It cannot be done overnight. Sometimes it takes years, but it is possible. And there are some companies who have embarked on this journey for a very long time, like Spearbank One is one of the companies that has been doing this for a while. If you haven't listened to these podcasts, I strongly recommend doing that. They specifically mentioned pairing mobbing integrated with trunk-based development. They also do TDD. And there's a wonderful talk by John Wilson at the FastFlow conference in October, where he talks about how they do ensemble programming at Booking. So I strongly recommend watching that video as well. So there are many more testimonials about these practices, but I couldn't really mention them all. So there are some prerequisites for T-Study. As I said, it's not easy. We need to embrace a mindset where we work with small pieces of work. So we need to be able to break down work into vertical slices that are really, really small. We need to have a mindset of shared ownership. So there shouldn't be any ivory towers or people who have the little kingdom and they want to preserve that kingdom. There should be shared ownership, shared knowledge. We need people who are happy to constantly communicate. Not many people are willing to do that. So that's another trait that's fundamental for these practices. We need fast feedback loops. So we need infrastructures that allows us to get feedback really fast. For example, having a slow testing infrastructure doesn't help in this case. So we need to fix that before we can move to these practices. And above all, this is a very, very important point. We need psychological safety. So people must be feel to safe. They must be feel to speak up. They shouldn't be afraid of asking stupid questions. There are no stupid questions. Their ideas should be listened to. They should be able to experiment, admit mistakes. And obviously, this requires a lot of air support from management. There are also some rules that need to be followed. We commit to fully test the high-quality change set into trunk every few minutes. This is the rhythm that these practices require. We never write production code without writing a failing test first. So that's the TDD mentality. And we value every person's ideas and have strict time limits. It's important that when we mock program, we work according to specific cycles. Like I always suggest having 90-minute cycles because that's how our brain is wired. We need to have pauses. We need to give people space to relax. And we need to have a hard deadline at the end of the day to go home. Don't think about work anymore. We're going to meet again tomorrow morning. Sometimes it's hard to establish these rules, but they are absolutely necessary not to make these practices exhausting. And obviously, we live in the AI days. So where is AI in this whole picture? AI amplifies the value of T-Study by shortening the feedback loops even more. Because agents are so fast at producing code, validating ideas, experimenting, creating POCs, it's really amplifying the value of these practices. The agent can be considered another member of the team and used as another member of the team. And it can also follow strict TDD rules. I've created Claude Code agents that are able to perform TDD really, really well. And that's really useful because we can fix design problems in each of the phases of TDD, either in the red phase or green phase. And that's extremely helpful. I know all of this might sound very weird to some people. So if you want to start this journey, I can help you out. We can help you out. I'm Makuni. So either connect with me on LinkedIn. I'm always very, very happy to talk to people about these practices, or you can do that through our website. And I'm done. Thank you. I can't quite hear you, John.
Sorry, it's been a long day. Sorry, I forgot to press unmute. I need the T-shirt that says "You are muted" written on my front here. So, great stuff. Thank you very much, T-Star-D. Definitely the way that I've been doing this stuff for a long time. TDD is not new for a lot of us, for sure. What's the take up with TDD? That seems like there's a lot of like in the developer circles that I at least frequent, or in my developer world, in my head, it seems like TDD seems to be the hardest one to accept. Is that your feeling as well?
Well, all these practices are really hard to accept.
Okay.
TDD is hard. It's because it's counterintuitive. But the reality is many people are confused about what TDD actually is. There is a lot of bias towards TDD that I see in the industry. And when I try to explore the reasons that people offer against TDD, I almost always discover that what they're doing is not TDD, or they don't fully grasp the basics. And so it's many times it's a you're doing it wrong situation, which is an annoying thing to say to people,
Yes.
obviously. But it is true that sometimes it's like that. Well, test-driven development is counterintuitive because it basically reverses the mechanism of writing code, right? People go like, why should I be writing tests first? And some people think that writing tests first is a waste of time because things change all the time. The reality is that there is no real alternative, because there is a confusion in the industry that going fast means ignoring some basic quality gates, right? Like writing tests, right? And so if I'm testing ideas very, very quickly, why should I be writing tests? Well, the reality is that many times what starts as a POC ends up in production as version 1. And some I've seen so many systems that were developed like that and carried problem for many, many, many years because quality was ignored at the start, which kind of set the tone of the system. So I always try to recalibrate that. You need tests, and if you need tests, test-driven development allows you, makes you do that the best way, because you are not focused. Your tests are not biased on what you already written, but you start from a behavior, and you're testing that behavior really, which is really what we want to do with tests.
I like your acronym. The only one that I would probably espouse is Git work trees, which are gaining a lot of popularity, obviously, these days. Cursor is obviously pushing that quite heavily, obviously. For those who don't know, you got these multiple working directories tied to a single Git repo, and work trees are becoming increasingly popular. So I don't know how T-Star-D will follow into that nice sort of, because you're talking about trunk-based development, right? So it's like work tree based development, I guess, or something to that effect. So
I don't know if people want to call it a different way. I'm totally up to that. I'm not going to register this trademark. It's just a way for me to communicate that.
Yes.
I've seen these practices work together really, really well. They kind of naturally fit together. So
yeah, there was this this white paper that was written by our field CTO Bob Walker. This was entitled "Achieving Continuous Delivery," where he actually goes into he dubbed the acronym TPF, which is trunk-based development, progressive workouts, and feature toggles. Okay. So this is something to consider. If you guys want to check this out, it's up at /publications, and there you'll find a whole bunch of resources that you can check out. We've got our white papers, we've got our State of GitOps report, et cetera, et cetera. Anyways, awesome stuff. Thank you so much for the presentation. That was awesome.
Thank you so much.
Thanks for being part of Shipped. All right, folks. We've got 2 more sessions to go. Can you believe it? We're almost done. All right, let's go ahead and get into the next one.
Hey everyone, welcome to SHIPPED25. Today I'm going to talk about Spec2Ship, integrating like a GitHub Copilot and Octopus Deploy for AI-driven delivery. I'm Sivamuthukumar, working as Director of DevOps, Principal Architect at CEI, and we are like an Octopus Deploy partner. So let's get started. So where we are right now, the AI development revolution, what like really changed? The development landscape has like fundamentally transformed, right? The developers are like now writing code using GitHub Copilot or any AI-powered development tool. So they are like writing specification rather than code, so that like the AI agents can understand the specification and generate the code. So this is like turning weeks and weeks of development into like hours. So this is not like just an incremental improvement. This is an acceleration, a 10x acceleration in development cycle. That's how like it's reshaping the entire software development lifecycle. So the ideas flow from concept to production faster than ever. It previously take like sprints. Now it takes like hours. So the bottleneck has shifted from writing code to ensuring like a quality and trust. So the reality check is the speed introduces like the new challenges, like how are we going to trust the code, which we didn't write line by line, and how are we going to track what's AI generated and versus like a human crafted. The major important question is how do we deploy safely when velocity increases like a 10x? So the speed is great, right? But can we ship AI code with the confidence? That's the question. So in this presentation, I'm going to walk you through how GitHub Copilot is generating the code and what are all the measures we can take from Octopus Deploy perspective so that like we can identify what code is generated by AI, and if it is generated by AI, what are all the different policies, what are all the different rule sets we can like integrate as part of the Octopus deployment channel, right? So let's get started here. The challenge, right? So the challenge, let's look at the traditional approach here. So the traditional approach, the specification move to like a development, and once the development is done, the code will be like a reviewed by peers or code will be reviewed by like a the team here, and then the reviewed code is like moved to test and deploy. So that's like the traditional approach. The timeline is taking like a days to weeks per feature, and the control perspective, it's like a high confident, but it's a slow delivery. So the AI without process, right? The spec is like a generated to the code using AI, and then it's going to like a production. The timeline is ours, but as we have like said, whether it's safe or who approved this, what are all the audit trails, and whether it's like going through the necessary governance and approval policies. So what we need is we need like a speed of AI generation, but we need like visibility into origins, and also we need like confidence to deploy and automation that scales. So that's how like we are going to introduce this governance process for the Copilot generated code and Copilot generated feature to have additional policies and additional constraints to make sure the AI generated code is like following the special path or special pathway to identify this is like following the best practices. So the solution, right? It's like a best of both worlds. So the GitHub Copilot perspective, it's like the AI powered code generation, obviously like a transforming specification to implementation. Previously, like a Copilot is working in the IDE. It helps the developer along the way, but with the GitHub coding agents, you can like delegate the task to the coding agent, and coding agent is like taking care of generating the code from your specification in the cloud itself, right? So it's like a very less working with humans. The coding agent is taking like one step further because you are like providing the specifications, not only the business specification, you are providing the technical specifications also, so that like the agents can do like a step by step what are all the steps it has to do when it's like generating the code. So the Copilot is like going one step further. So you are like dealing with multiple coding agent, including like the custom agents, right? And the other world is like the Octopus Deploy. So the Octopus Deploy, like it's an enterprise grade deployment automation. Now we can like set up the intelligent pipeline so that like it can recognize whether the code is generated by AI or like whether the release is like having the AI generated code, so that like it can deploy with the confident with like a additional automated validation it can introduce. So you can like use the smart deployment pipelines and the progressive rollouts and automated testing and validation and having like complete visibility and audit trails. So for example, like if in your traditional release process, if you are taking the code from development to QA to staging and production, but like more fast paced AI generated code, you can like take that into sandbox development, testing and production. if you need like a more validation, like a isolated validation, you can have like a sandbox environment. But if you don't want, but like you are looking for more approval gates, like a AI generated feature, completely AI generated feature, need like additional approval gates, you can like have a different channel or different lifecycle, so that like it can understand this particular feature is like a completely generated by AI agents, so that like it can take the different path in your Octopus deploy. So the story together, it is like you are able to ship like the AI generated code with like more confidence. So these two integration, right? The GitHub Copilot and then how Octopus deploy like works, that bridges the gap between the AI speed and then the deployment specific safety requirements. So it's giving like the best of the both worlds, right? So the Copilot can focus on generating the code, checking the quality, checking like the security vulnerabilities and other stuff. And then Octopus deploy governance policies can like focus on how the AI generated feature has to follow certain path or certain like policies and governance. So you can like deploy that in like the deploy AI generated feature with like more confidence. So let's go to the architecture, right? So as everyone know, like the spec to production typically like starts with the term like a spec to code. Um, Here, like we are extending that to the shipment also, like spec to ship or spec to production. So it starts with like the product specification. So you can like write requirements in spec.md, or you can write requirements in GitHub issue using like the natural language description what we want to build, right? Then you can like assign the GitHub issue to GitHub Copilot coding agent. So the Copilot coding agent that would be able to transform the specifications into implementation. It can like generate complete features with context, and also with the GitHub Copilot custom instruction, you can like specify what are the steps it has to do, and what are like the steps it needs to like taken care for build validation and other stuff. So the third one is like the automated testing and tagging, right? So this is where like the GitHub Actions is coming in place. So the GitHub Actions won't CA portion, the continuous integration portion. So the GitHub Actions run like a test, security scan, and tag like the code with the AI metadata. So you can like have a GitHub action to identify whether this is like generated by your team members, or it's generated by like your team members in association with like a coding agents. So you can like tag that code if it is like include, if it is like having the GitHub Copilot agent involved, so that like your package or your artifact that has like the metadata that's having related to the AI metadata generation, right? Then the Octopus deploy comes in. So the Octopus deploy like orchestrate the rollout across the different environment, like a dev, test, staging, and production. So here we are using like the AI policy validation or additional security checks and full audit trails to make sure the AI generated artifact that's like ready for doing the deployment. So that's where like the Octopus deploy is like really coming into the place. Like okay, the code is generated, the artifact is generated, but I'm going to have additional governance or additional policies to make sure the AI generated code is like going through certain pathways or like certain policies or like a certain approval workflows, so that like we have two different channels or two different life cycles. One is for like more the standard life cycle, and another one is for like more AI generated life cycle. The AI generated life cycle, you can like modify as needed, right? You can like include more controls, or you can say like okay, I want to deploy it in like a isolated environment, as we have said before, to have like more testing around that. So that's like the overall architecture, like how we can move from spec to not only the code, spec to production with the GitHub Copilot, GitHub Action, and Octopus deployed together. So where it starts with like the AI metadata. So we need to understand like how the code is generated. Is it like generated by AI? And you can have like the additional metadata, such as like what tool that has been used, and when like this tool is like merge the code, and whether it like security scan processed, or whether it has like any vulnerabilities. So you can add like these metadata as part of the variables when you are creating the release, so that like it can take like a different pathways when you are like passing it through. So this would give like more complete visibility, right? And also like it would enable you to have like the smart routing, so that like whenever like you are doing the release in your deployment targets, the smart routing can help you to like follow through certain process. So let me show the demo so that we can see this in like a action. So here is the GitHub code base. It is like a Node.js API. So we have like a Node.js API here in like the source folder. So in this one, we have like the GitHub Copilot also enabled, right? So basically, like in the GitHub Copilot, you can create an issue and then assign that to the GitHub Copilot so that like it can work on that. For example, here I have like a couple of like the agent sessions. So you can see the one session is like I have added the structured logging for HTTP request. So basically, like I have created a spec and assigned that to the GitHub Copilot. So the Copilot coding agent that takes the specification and starts working on this. So you can see here, like the Copilot is like working on this issue. And also you can see the session, how the Copilot coding is like working on this, right? So you can like go through the entire log here to understand. And the coding agent is like reading the existing repository, and what are all the changes it has to do. It come up with a plan, and then it's doing the changes, so that like you can review the files that has been changed by Copilot, and then you can like merge the pull request. So it's like a pretty straightforward, right? The coding agent is like understanding your spec, and it creates the code from there. Now let's go back to this one. So once like the pull request that has been created, it's going to trigger the GitHub actions. So let's say like the file has been added, and I'm like reviewing the code that has been generated by GitHub Copilot, and I look at the changes, everything looks good. So I'm like here I have like reviewed all the changes, make sure like this is fine. So I'm going to like merge the code, right? So once merge the code, that's where like the GitHub action is triggering. So we have the GitHub Actions workflow here. That's like basically the build and ship. So in the build and ship, you can see it's doing like the npm install, running the npm test and all. And also it's like creating the package. So the npm run package, that would be like taking care of creating the package for this node artifacts, right? And if it is like a merge to the main, I have used like the Octopus Deploy action. So basically like this is uploading the package to the space I have, right? So whenever like I have merged the code, the Octopus is like creating specific version of the package, and then upload that package to the Octopus Deploy. And once it's done, I have a code here to basically detect whether this is generated by human or like my team, or it also like co-authored by Copilot or coding agent. So I am like detecting this one by like a commit message and commit author, because typically like the Copilot coding agent generated commit that has like a co-authored by text. So if it is like generated, I am choosing the AI generated channel. If it is like a human authored commit, I'm choosing the default channel. By this way, I'm like detecting, okay, what kind of channel this release has to go, so that like based on the channel, I'm having a different lifecycle attached. And once the package is like created, once the release is like created, the Octopus deploy will like doing the deployment here using the Octopus release deploy, right? So let's take a look at from like the Octopus deploy perspective. So in Octopus deploy here, we have the project, and in this project, you can see we have like the release also, right? So let me show you like how the releases looks like here. You can see it has like a multiple release, and also I have like a couple of version here, right? The 1.0.116, that is like purely authored by me. So I have a channel like the default channel. But if the release is like identified or generated by the GitHub Copilot, then the 1.0.119, that is like going through the different channel, like the AI generated channel. So based on like what metadata we have like identified in the GitHub action, we are like passing it through like different channels here, like the default channel and the AI generated channel. And also each channel is like associated with its own life cycle. For example, the default one follows the default life cycle, and the AI generated one follows like the AI reviewed life cycle. So we have like a different steps for this life cycle, so that like the AI reviewed will go for like a additional manual approval process or additional validation checks, so that like we are making sure the AI generated output is confidently like deployed to the production. So that's how like it works. I'm like showing that it's just like the basic example, so that like we can have how we can like identify and how we can like set up the different policies. But you can like extend this to like a more sophisticated way, so that like you have multiple channels based on what kind of like the output you are having, or like what kind of feature you are developing, and how you want to like handle the AI generated or AI reviewed artifacts in like a different ways. Okay, now let's go back to the slide here. So we talked about like the metadata and the smart deployment pipelines. Now like the flexible deployment channels, right? So this is the channel like we see, but just to give like the additional best practices or additional tips, the different situation demand like a different workflows. The channel based approach is like make sure it's ensure like the right balance of speed and safety, but you can bring it in the way like the standard channel, that's like the human written code following like normal development workflow, right? And the AI generated channel, like code generated by GitHub Copilot or any other tool. We have like identified the GitHub Copilot generated code because that code process is like going through the coding agent. But if it is like used in the IDE, you may need like a additional label or like additional process there to identify this code is like generated by the Copilot, right? And the validation, you need like a enhanced testing or code quality checks. You can do that in the GitHub action. And the approval perspective, you may need like a additional review for staging and production. You can like implement that using Octopus Deploy deployment channel. And also the fast track channel, you can like make sure you can have like the expedited review, because that's where like it's more speed and quality. You cannot like have more approval gates in there, right? So the fast track channel, even though the AI generated, you can like take some risk based assessment to make sure you can expedite the review process for like the post deployment. So these are like the three different deployment channels you can create to have the normal development workflow and the AI generated workflow, and then the fast track workflows. So finally, like the spec to ship workflow looks like the GitHub Copilot creates code, config scripts based on the specification, right? And the validate portion that has been like covered by GitHub Actions. So the GitHub Actions run like a automated test and security scans. And the govern portion, that's where like the Octopus deploy comes in. So it's like making sure it enforcing the life cycle approvals and compliance process, so that like only the verified artifacts ship to production with like a full traceability, right? So this framework like ensure that the AI generated code moves through like a structured pipeline where like every stage add additional verification or accountability and control, so that like you have the complete spec to ship with like more confidence. So how to start like your AI powered journey? So obviously like from the adoption perspective, the GitHub Copilot. So start like using the GitHub Copilot. Obviously like the GitHub Copilot, not only from the IDE perspective with like a coding agent, you can like do the coding, you can delegate your coding task to the agents, and you can like create a custom agents also to have like your task specific agents or like a purpose built agents to do the coding. So the coding agent will like generate the code as we have said before. So the AI metadata tagging, that's where like it really helps to understand whether this is like generated by human or like generated by GitHub Copilot. So you can use those tagging in your CI/CD pipeline using GitHub Actions, and you can add like additional controls such as like security scan or enhanced validation to make sure the code is like really go through the security process, right? And then you can like use the Octopus deploy channels as well. But make sure like you are iterating continuously on the process. It's not like something you need to introduce based for like just to detect AI generated code or not. If your like a process really demands the additional like governance or like additional validation in your spec to ship process, then you can like start building those things in your like Octopus deploy. And the other thing like the common mistakes to avoid, don't like make the process too heavy, right? So this is like just to understand what are all the different channels, or like what are all the different process we need to take. So don't make like the process too heavy, keep it like a lightweight, and make sure like you are having the overall governance and policy, right? Anyhow, like the human generated code or AI generated code, it's going to be the same when it comes to the security and the governance perspective. But with the AI generated code, we are taking like additional steps to ensure that's like having more secure code, right? So improve the process continuously. Once you set up like you can continuously like improve the process. So that's the overall like the spec to ship workflow looks like. So as we said, in this moment right now, the code generation part that has been like drastically improved, right? Previously, like we spent more time, more days to understand the specification, to build the code, and to generate like the feature. But now it's like so fast from the coding perspective, and the GitHub Copilot and Octopus Deploy and GitHub Actions together, that's giving like the complete governance to make sure you can like take from spec to ship in like a more faster way, and also like a more control and secure way.
Awesome stuff. Thank you very much. We are now at the last session. And Alex, I'm going to go ahead and invite you to the stage. Hopefully we can hear you. Go ahead and test out your audio.
Hey guys, can anyone hear me at all?
Yes, you are loud and clear.
Amazing.
Yeah. So Alex pinged me, I think it's about a few days ago, and she was saying that, hey, do you need another speaker? I can do my talk on how to manage the rollout for a massive rewrite. And I was like, that sounds really cool. Unfortunately, we had no room at the end of the first day, so we had to put her to the end of the second day. So Welcome, Alex. Thank you very much for joining us. Let's go ahead and get you set up here. We'll set up you on stage. Lastly, but not leastly, thank you very much for doing a presentation. Over to you.
Thank you so much, John. Hi, everyone. Please bear with me for a moment while I get my all my stuff ready to go. All right. Thanks. I'm so excited to be here. I really appreciate that John was able to fit me in. So this is a talk that I actually prepared for the Melbourne SRE meetup. And so I hope that you guys will enjoy a little bit of an insight into some of the stuff that we do behind the scenes at Octopus Deploy to keep everything safe and to keep you guys, working well. Cool. So what I'm going to talk about is a massive refactor that we did recently, where we basically refactored everything everywhere all at once, and how we tried to release that really, really safely. So just to give you a little bit of context for this talk, because we're going to zoom in and then we're going to zoom out again. First of all, I'm going to give you some of the context about Octopus Cloud in particular and how that works. I'm gonna do some scaremongering about what releasing a large-scale rewrite can be like in some of the ways that I've certainly done it wrong. And then I'm going to talk you through the things that my team decided we wanted to do this time. Like, what does a really good large-scale refactor release look like when it's happy? And that led us to some quite interesting principles, this mix of our constraint, the constraint of the interesting Octopus context, plus the way we wanted it to go. And so then I'm going to tell you exactly how we did it. And then I'm going to go through and sort of connect what we did to our solution to explain it a little bit. And then I'm going to talk a little bit about hopefully how this, what you can take away from this, right? What might be interesting for you, given you probably don't have an identical context. And I'll finish up with a little bit of how it's going. Awesome. So Octopus Deploy is actually a 15-year-old product. And I'm sure most of you will be aware that in the last 15 years in the technology industry, we have learned a lot of things about how we build resilient and scalable systems. And so we wanted to rewrite the core engine of Octopus Deploy, the what we call the deployment pipeline, the thing that actually executes the deployments that you guys are doing on our software hundreds of thousands of times a day, sometimes. So we wanted it to be event-driven, and particularly we wanted to use an event-driven system because it gave us these really great properties of resiliency and scalability. Now, I'm showing you the slide. You do not need to grok this slide. I found the slide when I was going through our really beautiful custom presentation templates. This is a slide that our sales team uses to explain what we do, all the different things that we do. And what I really want you to take in from the slide is the absolute chaos of the slide. There is so much on the slide. So when I'm talking about a deployment capability, and when I'm talking about refactoring our deployment pipeline, what I'm meaning is rebuilding or refactoring all of these different features, like taking things from Jenkins or GitLab and deploying to any different cloud thing, maybe running some Terraform. We're currently working on SSH targets, all that sort of stuff. And so again, maybe you guys don't need this context. This talk was originally written for an SRE meetup context where they might not be that familiar with Octopus. This is another default slide template slide where you can see that Octopus Deploy just kind of sits in the middle here of, you can connect up so many things. We can take your artifact, however you want to define that thing, and we can help you put it anywhere at all, basically. So see how we are the common bit in between. So I'm going to talk about that pipeline of how we do an actual deployment. So TLDR, deployments are complex. And when I was speaking to the group of SREs, I know all of you are amazing and you use Octopus because you see the value in not having a 10,000 line bash script that has a million different branching paths to run your deployments, right? But to be clear, the kind of deployments here that I'm talking about are basically Turing complete. They're just wildly complex. So Octopus Cloud, we run Octopus Cloud in a single tenant model. So every single customer has their own instance. We run that as a Kubernetes pod. And they also have their own database. We tend to run the databases on an Elastic shared cluster. And this sort of architecture gives us really, really nice safety and isolation for our customers. But one of the things that becomes really, really interesting about this is because there are thousands of cloud customer instances, and because deployments are this wildly complex, wildly varied beast. Remember, this has been running for like 15 years. We wrote a lot of deployment features in that time, guys. There's a lot of stuff in there. The reason this talk is called Everything Everywhere All at Once is because our customers can do so many different things. It can be extremely hard for us to extrapolate out usage patterns. So we struggle to define really, really clear and useful archetypes, right? Our customers use all of our features everywhere, all the time. We do not really get a break from customer usage or any of that sort of stuff. And additional context that is going to be important as we go through this talk. Octopus Cloud is not a set of microservices. We have a majestic monolith, a well-factored monolith, I would say, right? So each of those instances is essentially running only a single application process, the Octopus server application process, the very same one, the very same binary that you will run self-hosted Octopus for if you are running self-hosted Octopus. So one of the ways that I have released a big refactor in the past has been something akin to a Big Bang release, right? And those have gone wrong in a myriad of ways for me. They tend to be a little bit risky. So things that I personally have seen, a Big Bang release where you have more problems that you can fix. Something where you have chosen to do some sort of one-way door, where you can't actually get customers back to the stability where things were working before. Often if you release large chunks of stuff quickly, or you're releasing like a new architecture that is a significant rewrite, you will have intermittent problems, and they're really hard to diagnose because you're not familiar with how everything is operating yet. And finally, customers are sometimes upset at things being changed. And, if any of these things were happening to me as a customer, if my bugs weren't getting fixed, if I was in a broken state and the developers were telling me that I was just going to have to wait for weeks to get it better, or if there were intermittent problems that the team didn't seem to know what to do about, I would be not too happy either, right? So I think one of the really important things to note for our customers is we understand the trust that our customers place in us. Deployments tend to be mission critical for any business, right? Particularly your production deployments, and the level of trust that they have in us to allow us to connect to their secure production systems. We take those things really, really seriously, right? And so these were the principles that we came up with to try to, I guess, deserve the level of trust, or make sure our customers can trust us the way that we think they should, right? So one of the things that we went through was we're doing this big rewrite. One of the ways that Octopus often releases features is we do a GA. And customers, especially for some of our super cool like Kubernetes stuff, maybe our ephemeral environments things, these really exciting features, our customers are excited to participate in the GA. Some people love being early adopters. They want to try stuff out and they give us really great feedback. That's a hard sell when the feature that we're giving you is scalability, performance, resiliency. We had a feeling that if we tried to get customers to opt into a GA of resiliency, for example, our customers were going to tell us to piss off. Fair enough, because you should expect us just to give you those things. Those are the base level expectation that you should have for us. So we didn't think a GA was going to be a good option. And at the end of the day, we think you guys should expect it from us. And one of the things that has driven us all up the wall before is trying to force a customer to understand some internal property of the system, of how they build and operate the system, that doesn't matter to me as a customer. So I don't know about you, but I suspect you will have had a similar experience where you use a tool, perhaps one that you don't use that often, and for some reason, you can't use a certain feature. Not because you're not on the right tier, not because they're trying to squeeze money out of you, but because you built something up 5 years ago and they've since switched to V2 of their tool, but they expect you to manually migrate. They want you to take on the mental complexity of them running these things. So we didn't want to do that to our customers either. Deployments are hard enough as it is. In a perfect world, your deployments are going perfectly. You shouldn't need to know how Octopus is doing in the background, right? The next principle that we came up with was customer deployments don't fail twice. Got a little asterisk there. We can argue about whether we achieved that and whether that's exactly what it meant, but this just comes back to what I said before. Deployments are mission critical. We can't tell what a production deployment is. One of my favorite stories from a very good friend who was a DevOps consultant for a couple of years was that they had this customer who were doing a lot of work with sort of resiliency in some of their environments, particularly in their test and production environments, not so much in the UAT or horse environments. And we all just had so many questions about what the horse environment was. So look, there is, if you think about it really, unless you very conveniently call an environment production or tell us in some way, we don't have any way of knowing what's really mission critical for you and what's not. So we have to default to treating everything you do as mission critical. And I don't think that's a bad thing. So then switching to look a little bit more internally for the experience as someone working on the Octopus code base. Octopus continuous delivery. We wanted our devs to be able to ship continuously. This is kind of important, right? We do what we say, basically. So we wanted to make sure that we were getting our developers feedback on this new pipeline that they were rewriting, not right at the end, not in a big bang release once everything was ready to go. We wanted to get feedback as early as possible to make sure that all of the things that we thought it was going to do were going to work. And finally, remember how I said we had thousands of cloud instances? That already can make understanding the state of your cloud, of your cloud environments quite hard, because of course all of those thousands of instances are not going to be on the exact same version of your code at the same time. So we wanted to make sure that whatever we were doing, it was easy for our developers to reason about, to understand, hey, if this customer hit this problem, what was the state of their instance at the time? What version of the code were they running? How were they using the new pipeline, basically? Cool. So the solution, as promised, we called it the Enthusiastic Execution Pipeline Selector, and because I'm a sucker for a cute nickname, we called it EAPS. So if I say EAPS, just know that I'm referring to this particular piece of software that we built. So in this SRE meetup context, I sort of joked a little bit, right? I'm a software engineer. I'm a lead engineer here at Octopus Deploy. And so unlike a lot of SREs or DevOps folks, my solution to the problem was just to write more software. And so we wrote this thing called EAPS. So we called it the Enthusiastic Execution Pipeline Selector. And remember, the execution pipeline is the thing that actually knows how to run your deployments. It's enthusiastic because it will try to run as much, every single deployment that it can on our new V2 pipeline, unless for some reason it has to run it back on our previous pipeline. So, we wanted to get as much feedback on the new pipeline as possible. So we wanted this kind of enthusiastic paradigm where we were running as much stuff on it as possible, as early as possible. This led to one of the conclusions being essentially that we had to maintain both the V1 pipeline and the rewritten V2 pipeline inside that same monolithic code base at the same time in order to enable this switchy behavior. Cool. So here's a little diagram that just digs a little bit more into how EAPS works. So rather than analyzing something like a whole customer instance or anything higher level, this thing runs every time you hit the deploy button. EAPS kicks in, and it has a few different, 3 different features really. It has feature analysis, so it knows what deployment features that you might be using. And remember, we spoke about this before, so this might be something like upload to S3. This might be something like a Kubernetes target. It might be something like an offline drop. It understands the different capabilities the Octopus server has, and it knows which features that a given deployment, at the point that that deployment is run, is using. And so it analyzes that. It kicks into the selector mode, which decides to run that deployment on the V1 pipeline or the V2 pipeline, always preferring the V2 pipeline. And then once that deployment has completed, it does some anomaly detection. So when I say an anomaly, we were looking for a few different things. It looks to say, hey, did this deployment use a feature that I didn't detect in my analysis? So basically checking that our analysis was working. It checked for the runtime of the deployment to say, hey, if you ran on the V2 pipeline, did you take a really, really long time? Did something go wrong in some way that perhaps wasn't an exception or caused the deployment to break, but was still not acceptable for our customers? Or did the deployment actually fail? Did something go wrong during the deployment? So those are the 3 components of what EAPS does. So digging into that first principle that customers should expect resiliency, scalability, and performance by default, and particularly they shouldn't have to be aware of the V2 pipeline. They shouldn't have to, when they are building their deployment pipelines, try to build in this new world. Everything should just continue to work exactly the same as it did before, but a little bit more resilient over in the new world. This led us to the conclusion of EAPS. This was one of the things that led to that pipeline selector part, so the part that picks V1 or V2. So given that we had thousands of customers, and each of them can have hundreds of customers, remember customers running everything everywhere all at once, we decided that there could not be a human in the loop. There had to be a piece of software that was responsible for making those decisions. So the context specific to Octopus Deploy that may be different in your world was that deployments are this kind of long-running background work. Once you hit that deploy button, a deployment goes off and it's doing the work. It is showing you output, but it's not really interacting with you very much. We do have some steps that are a bit more interactive, but on the whole, it's kind of this autonomous process that kicks off and does stuff. And so that nature, where it's actually really long-running, really complex operation, that lent itself quite well to this kind of selector idea where you are either all in on V1 or you're all in on V2, and we determine that up front, right? For a lot of sort of applications that tend to lean more on like CRUD operations, not long-running kind of processes, this kind of paradigm of runs in V1 or runs in V2 might not make as much sense. Our second principle, customer deployments don't fail twice, right? And this is kind of trying to mitigate that failure mode that we talked about before of this kind of one-way door where a customer might get stuck on the new pipeline. If we do a migration, if their deployment doesn't work, we've migrated them to the V2 pipeline and we can't easily switch them back to the V1 pipeline, that leaves them in a broken state. And for their mission critical production deployments, which remember, is all of them, we don't want that. So we needed to make sure that there wasn't going to be a human in the loop having to bring them back into safety, and that that it wasn't a one-way door, right? And so to implement this is what led us to the decision of building the EAPS anomaly detection, so that we knew if it was going wrong, and also the pipeline selector part, right? And I sort of mentioned before that to do this, we maintained the V1 code in parallel with the V2 code. That's a not insignificant burden on our developers, but we found it to be worth it for the safety of being able to say, if a customer fails, we have a safe place to send them back to. We know where we can send them back to, and we know that V1 is going to work because we're not changing V1, we're keeping that intact as we go. Cool. And so some of the useful context for this, for Octopus Deploy, is for us trying to figure out if a deployment, if a customer is having a bad time, if a deployment failed, deployments inherently have a pass-fail quality, right? Your deployment will, you'll get a green tick or a red cross when your deployment completes. So it was very convenient for us that we didn't also have to build analysis of whether a customer is having a bad time, because the deployment itself can tell us. There's a little caveat here that if we have time for questions later, ask me about it and I can dig into, because this one is really interesting about what does a customer's deployment being successful actually mean. Cool. So the third principle that we went through was that internally our developers can ship continuously and get feedback early. So we are constantly upgrading our customer instances. And in fact, part of the reason that we ran this project was that we wanted to be able to upgrade customer instances more frequently without having any kind of sort of downtime for the customer. And so, yeah, our developers needed to be shipping continuously and getting early feedback on the V2 pipeline as soon as possible to ensure that we knew that it was going to do what we thought it was going to do. This led us to two of the EAPS features. Again, that feature analysis one, and then the pipeline selector. So the feature analysis thing, understanding what a customer's deployment does at the point that it's run, allowed us to defer our decision about which pipeline that it was going to run on up until the very last second, right? Up until the point that they actually hit run. And so this meant that as we ship new versions of the code, because it was the code that was deciding what pipeline to run on, it knew what version it was running and it knew what it supported and what it didn't. And so this gave us the best possible chance of automatically opting customers into V2 and of allowing us to easily kind of start using new features as we developed them, right? So yeah, the next part, the selector, this allowed us some level of safety, because one of the things that we did was we toggled that selector behavior. So remember, we would run the feature analysis, we'd say, can it work on V2? If it can, it does. It would then go into the selector that would usually select V2 in that case. We could toggle that off. We could just say, hey, if one customer has failed for some reason, we will stop all customers running on V2. We'll send them back to safety. And so this gave us a safety net to have some confidence that developers could ship, which is slightly higher risk, knowing that we had a place of safety to send our customers back to if we started being concerned about any impact to customers. And so again, the context for that is this kind of single tenanted cloud environment where they are their own little world, and it's very hard for us to kind of reason about all of the customer instances at once when they might all be running different versions of the code, right? And that's part of why we tied the decision of what to run to what code was actually running on the instance at the time. The final principle, our developers can understand the state of each customer instance. Stuff is going to go wrong. We need to be able to understand what state they were in and why things went wrong, basically. And so again, this is where the feature analysis kind of thing came in. And a little bit that sort of top level feature flag that I talked about, the one that controlled the select behavior. One of the things that we were keenly trying to avoid here was a Cartesian explosion of feature flags. So we had hundreds of different deployment capabilities that we were rewriting to work in the V2 style. If you imagine trying to understand the state of a particular customer instance where they may or may not have a feature flag enabled, may or may not have a selection of, let's say, 100 different feature flags enabled across maybe 10 different deployment processes in their one instance, across thousands of customers, that kind of explosion of possibilities, of combinations, made it really, really hard. So having the feature analysis and the decision tied to the code meant that it was very easy for us to say the state of a customer's instance, the state of these decisions is in the code. And so I can look at the version of the customer's instance when something goes wrong. And by looking at that version, I will know all the information I need is inside the code, basically. And of course, we paired this with a whole lot of monitoring, alerting, and telemetry as well. Yes. So I think I just explained the part that was meant to go with this slide and the previous slide. You get the picture. So why did this work for us? What's going to be different in your world, perhaps? So the things that enabled us to take this approach were the fact that we decided this really, really early on. When we were very early in this event-driven rewrite, we said, essentially, we want to start thinking about how we release this now, and we want to start getting feedback early. If we had already progressed further along the path, if we had already started releasing when we came up with these principles, it would have been a lot harder for us to retrofit on the kind of approach that we ended up taking. And we looked at the constraints first as well. We looked at stuff like, we don't want a one-way door. We don't want customer deployments to fail twice. We don't want to force customers to think or even know about the V2 pipeline if they don't have to. So having those things that we didn't want helped us decide what we do want, which then led to us deciding what we needed to build. And we had quite a large team. We had a lot of developers available to write this code and to manage this code. If you didn't have as many devs on your team, if you didn't have as much time available for developers to write code to manage something like this might be a little bit harder to do. And all of this is very dependent on the fact that this is a monolith. If this was a microservices world, I think we would probably be talking about a very, very different approach indeed. And finally, I flattered our monolith. I said it was majestic and well factored. It's true that there were very, very good boundaries in our code that enabled us to slot EAPs in at the boundary between at the point that the customer went to run the deployment, right? We were able to essentially snapshot it and control running a deployment with relatively little code change because the boundaries in the code were pretty good. Otherwise, it would have been very hard to kind of add a gate in there. So yeah, I've really enjoyed the way that we thought about safety first up front. And I think I would use something like this approach again if I were doing a large scale rewrite again. So a few numbers for you. As of doing this talk, maybe a month ago, a couple of weeks ago, we had 80% of deployments were compatible with V2. And so remember, that's deployments by volume. It's not deployment process, it's volume of processes that run on V2. Of that, we have about 65% of actual deployments running on V2. And just the fact that we can give you these percentage numbers that we are doing it per deployment execution, I think is a really interesting way of looking at it, because we're not talking about a customer or a particular process. We're actually looking at the volume of execution. And overall, I would say we have about 110% developer satisfaction. The team feel like this has given them the control that they needed and the tools that they needed to do this as safely as we could. So thank you all for your time. And I hope you've enjoyed this little insight into the world of Octopus Deploy. Thank you.
Awesome stuff, Alex. Amazing. I can't wait for this work to get done, and then we can just say, okay, what's the next major issue we can tackle? But that's a fantastic story to share and tell. And I can't wait for the metrics that customers will see in their own deployments. Of course, this will be part of the scale story. But yeah, awesome stuff. All right. Thank you very much, Alex. That is, believe it or not, it for Shipped. I can't believe it. We reached the end of the event. Yeah, so octopus.com/shipped. You'll see this website update shortly. It will point to our YouTube playlist, which has all the sessions that are recorded over the last 2 days. So /shipped/schedule. Those will be the two locations you can check out for more information. don't forget, we have our Octopus Fundamentals course, which launched as part of Shipped. You're all going to receive an email, not from me, but from our Shipped alias, with a voucher for a free course in this. So you can get your free Octopus certified badge for Octopus Fundamentals. You can get it from Credly. You can show it up on your LinkedIn. It would be awesome. If you missed anything throughout the last couple of days, you can see it here on our YouTube channel. As the kids say, like and subscribe, all right? So we really would love for you to subscribe. We actually post a lot of videos here, and we would love for you to subscribe to our channel and watch the shows that we have there. We have Deploy on Friday. We have Argo Unpacked. We have our Inside Platform Engineering series, which we just ran. We post videos up here all the time, so make sure to subscribe to that. Find a video that you like, etc. You can see that our playlist is already getting populated with all the content that was seen over the past 2 days. You can see all the streams. You can see all the sessions, etc. By the end of today, all the content that was presented over the last 2 days will be there. If you're looking for something in more of the live variety, don't worry, your journey still continues. You can go to /webinars and check out our webinars there. We've got one coming up in 2026, the first one of the year. It's going to be on Platform Hub, and in particular, Ships and Matt are going to be talking about policies, which is a new capability of Platform Hub, which is really exciting. And you saw a bit of that in the 2025 release party, which we hosted on day one. And then finally, we are hiring. So if you're at all curious about what you saw here today, and you're like, I want to be a part of that, check out our careers page. This is a new page for us, octopus.com/careers. Check out the roles that are available. We would love to have a chat with you. We're a wonderful place to work. I've been here for 6 years. I just passed my 6-year anniversary. There you go. But yeah, we've got roles that are open. We're a really awesome place to be, and we would love to hear from you at some point in the future if possible. All right, well, there you go. That wraps up SHIPPED25. That's the 3rd year we've done this. This is great. Stay tuned for an announcement around SHIPPED26. We'll make sure to do it again. And on behalf of all of us here at Octopus Deploy, thank you for your time and attention. This is a celebration of not only the work that was done by us, but also by you, our customers, our partners, folks that are doing really good stuff in and around the world of continuous delivery and continuous deployments. So, as always, happy deployments, everyone, and take care.